Hello, welcome to another stream. How about that? How about that? Welcome, welcome, welcome. Hello, Agduk, hello, Sodding TOS, hello, Mr. Brunk, Useless Pony, Twitly Doof, Darlington Sydney, Jeroen, John, hello, Useless Pony, did I say hello to you? Katison, hello, hello. Welcome, welcome, Sintuz, welcome, welcome, welcome. Hello, hello, hello. So today is Friday, hello, ThreaX2H. And that means today, according to the schedule, we're supposed to be doing a random one-off stream, but since there's currently Advent of Code in place, we are obligated to solve an Advent of Code problem. Jesus fucking Christ, I cannot talk today for some reason. So first we're gonna try to solve the day 17. And then if we'll have time, we're gonna do, one-off stream, Friday one-off stream. I want to continue the topic of the previous Friday, basically a spam filter in Haskell. So we already implemented a simple spam filter based on the naive Bayes theorem classifier. I think this is how it's supposed to be called. And it's pretty slow, but today I wanted to try to speed it up a little bit. I have a couple of ideas on how we can speed it up and improve the infrastructure of training the model and stuff like that. So if we'll have time, we'll actually do machine learning in Haskell. How about that? I think it's actually pretty cool. Funk Chi, hello, hello, welcome, welcome. Coding for unemployed people. God damn, you're goddamn right. Anyways, so today we're solving a day 17 in Scala. If you never heard about Scala, you're probably a Zoomer. But that's okay, that's okay. There's nothing wrong with being a Zoomer. It's just a weird timing. So yeah, this is the language which was a huge inspiration for a Kotlin, right? Kotlin actually borrowed a lot of ideas from Scala, and back in the days it was actually pretty very hyped language. And I think there's people still use that language in production because I mean at the time of the hype of that language, people wrote a couple of projects, and now it's a legacy code base, and now we have to maintain it. So yeah, borrowed. Yeah. Scala is used in big data like Spark. Yeah, I mean, people still keep using it because they're already dependent on it, so they cannot just easily switch from it anymore. So yeah. Hello, Alexor, Human Abstract, hello, hello. Alright, so let's start working on all of that. I haven't read the description of 17's problem, so I don't really know much about it. Hello, Rotten Chomsy, welcome to the stream. So let me fetch the latest changes, not prune. What the hell is going on with me today? Like there's something really weird. Yeah. Origin master. Okay, so yeah, I did a little bit of cleanup off screen. Essentially, I just extended the readmes of the problems. I wish GitHub was loading up a little bit faster. Okay, so essentially now, if you go into one of the folders, it will also tell you, you know, what is the version that I used and the expected result and stuff like that. I also plan to give to put a link to the screencast, because all of the streams are archived on YouTube, so you can find them here. So I want to, like, in the future add like links to the screencast to the corresponding problems where I solved them. So I want to like properly document the entire journey as I go. So yeah, that's why there is a lot of, you know, changes here. So they're essentially just, you know, cleanup with me, just additional stuff. So today is day 17 in Scala, right? And so you're supposed to use Scala with either IntelliJ IDEA, right? So you're supposed to use it with either IntelliJ IDEA or SBT. But this is a path for normies. We're not going to go there, primarily because IntelliJ IDEA doesn't really work well when I'm streaming, so I cannot really use IntelliJ IDEA and stream simultaneously on the same machine. Hello, Bill Janul, welcome to the stream. And SBT takes too much time to set up. Like you can easily download SBT executable, and you will have to wait until it, you know, bootstraps it up, and then you'll have to deal with the weird configuration of SBT, and I just don't want to do any of this stuff. Like seriously, none of these paths are for us, right? So we're not going to make this choice. We're going to go to the other ways to install Scala, and there's better ways to do that. So we're going to download the distribution directly from here. So let me put it somewhere. I think I'm gonna actually move it inside of the folder here. So here is the Scala, and I'm gonna move it right here. And look at the size of this distribution. Believe it or not, this is the whole Scala compiler. Seriously, this is the whole Scala compiler. We can unpack it. Scala is notorious for being overbloated and slow, but look at that. So yeah, if you take a look at the libs, there's like a bunch of jars in here. So there is a Scala compiler, Scala standard library, and that's it pretty much. That's the whole thing. And in the bin, you have a bunch of scripts, the starter scripts, specifically, I suppose this is supposed to be the repo, and I think Scala C is the compiler, right? But none of that is gonna work. None of that is gonna work unless you have a JVM setup. And both, hello, welcome to both. How are you doing? I found energy drink with CBT. Isn't that like a? How does it give you energy? Like it's supposed to, like CBT is very sedative as far as I know, and then in energy drinks you have a caffeine. Aren't they start like fight with each other, CBT and caffeine? Like it's really strange. Like why would you put it there? Like I mean, why the people who produce this product put CBT there? It's really strange. Hello everyone. So essentially, yeah, we need to set up. Some people drink coffee and alcohol. Yeah, it's true. Which is really bad, by the way. Like mixing up caffeine and alcohol is extremely bad. So for the health. Okay, OPT, and so I need to set up the Java environment. So we will have a Java, right, from the Oracle. Yes, we're using hotspot from the Oracle, the 13th one, the lucky one. So, and after that, if I run something like Scala, I will have a REPL of Scala. It's gonna take some time to start up, but after some time we're gonna have a REPL of Scala. But the famous White Russian. Oh, you mean cocktail? I don't know. I heard about it, but I never tried it. Is it like coffee plus alcohol? Well, I mean it's also quite bad. Okay, so yeah, this is Scala for you. If anyone wanted to see that, here is the Scala. So. Yeah, but it's like supposed to be sort of like a functional programming language. All right, so we have lists. And you know my favorite part of Scala? Okay, you can do map and you can have something like this lambda, right? And it iterates through the map and increments each individual number here. But you know what is my favorite part of Scala, which I never see anywhere else? This is equivalent to that. You can partially apply infix operators, and this is a lambda that accepts a single argument. So this is the syntax for a lambda. Like, this is so fucking clever. I mean, in Haskell it's a little bit more convenient because you can literally just partially apply infix, but I really like that you sort of indicate that. You have that. And on top of that, I think you can do like a but operator that looks like this, and it's going to be a lambda with 2 arguments, but I'm not sure how to do that. So I wonder if something like this exists. Can I do zip? Missing argument method zip in trait strict optimized. Okay, so can I do zip with 1, 2, 3? I can do zip, but can I do zip with? Right, zip with. Zip with is not a member. Yeah, so maybe if we had zip with, but I don't know how to do that. But it's sort of like a functionalish, but yeah. So yeah, and this is what we're gonna do today. So I'm thinking, how should I make it more convenient for myself to use Scala? So maybe I'm gonna move this entire stuff, the folder and the archive to OPT, and I'm gonna set up the environment bash as I did for Java and stuff like that. Scala is not slow. Well, the compiler is pretty slow, but you know, the code that generates, I mean, people use it for machine learning and stuff like that. I don't know. So I haven't programmed in production in Scala for quite some time. If you have 2 elements, you can do something like a reduce. Yeah, I know that. I programmed in Scala quite actively, but that was a long time ago, to be fair. So I do remember like a thing or two from that language. Anyways, let's actually move everything to the OPT, and I'm gonna set up the environment. White Russian, 2 parts halua coffee liquor, 4 parts vodka, and 3 parts cream milk, in case someone was curious. Yeah, sounds really unhealthy, so I'll definitely not drink that. But to be fair, I don't drink alcohol in general, so I wouldn't drink it not for the reasons of, you know, of coffee with alcohol, but because of alcohol. So what do we have here? So where is Scala? I don't see Scala. Here's a Scala. So let's do Scala environment environment sh, and essentially what we're gonna do here, we're gonna just export path opt Scala, and I need to know, can I control Z? I cannot control Z this thing. What the fuck? It's really strange. This is probably because I have to do sudo. Yeah, can I do? Yeah, I can do it now. So what's the version of Scala? The version of Scala is 2.13.4, and I can restore this thing. There we go. It's gonna be... What the hell is going on? Export path. Health and health, you're dead in few years anyway. Sure. OPT Scala. I think bin, and I think that's it. Yeah, I think that's it. So if I try to do source, Scala environment, right? And if I try to do which Scala, I do have Scala installed here. Nice, nice, nice. So I can go back to AOC and 17, and now if I do Scala, I do have a Scala property set up here. Nice. Many percent caveat. I mean, I don't tell people what to do. I just speak for myself. I say that I personally wouldn't do that because that and that and that, but I don't say that you shouldn't do that. Right? So I don't tell people what to do. If you want to live like that, sure. Okay, so let's do a boilerplate. So if I remember correctly, to start with an entry point, you have to have an object main, right? It's very interesting. It's like in Kotlin, right? You have objects and you have classes, and if you have an object, it's essentially as having like a static methods in your particular class, right? So and then you're gonna have main, which is gonna be entry point, and it accepts arguments, which is array of strings. So yeah. Types are specified after the name. Instead of angular brackets, you use square brackets, right? And you're not supposed to return anything, and then you can do println saying hello world. Or which hello world should we use, by the way? Should we use this hello world or the traditional one? I'm gonna go with the traditional one. I actually respect traditions. So, and let's try to compile this entire thing. So I'm gonna do Scala C, and let's do Scala C and see how many class objects, class files it will generate. Hello, Luke Gorilla. Hello, hello, everyone who just joined. I'm Dren. Hello, hello. All right, so let's take a look at. Okay, as you can see, it generated 2 class files for some reason because, you know, Scala. And now, if I try to run this thing, it will... No class defined pre-def. Very interesting. So it's the same situation as with Kotlin, right? It compiles the classes, but it doesn't include the standard library of Scala. So we have to think how to do that. So maybe Scala has a special flag similarly to Kotlin to generate jar with all of the libraries and stuff like that. Let's find out. Faster than Kotlin, yeah, who would have thought? We can, at some point, by the way, we can compare the performance, like compilation performance between Scala and Kotlin. I think that would be kind of interesting. Wait a second, what the fuck is going on? Less? Ah, okay, I'm really confused, but okay. Release. Use JavaCP, duplicated settings. So does it have anything about jar? Destination for generated classes. What about lib? Takes 10 seconds. I mean, yeah, it's a classical Scala. Okay, so we can try to Google that. I'm gonna do Scala C, include stdlib or something. I'm not sure if it's called like that, but what's the issue with Scala? Oh, you know what? I think I'm gonna do the following thing. I'm gonna just do this, and this should be a pretty common error that people see, and I'm gonna try to Google specifically that error, and maybe it will redirect us to something useful. How to address Scala error in Eclipse? Okay, maybe I'm gonna start with something like this. No class found per def issue. Okay, so is there any like good solutions for that? Alright, so you're supposed to do CP. Fair enough. It's not particularly convenient, but I can do that, alright? So Java CP, OPT, Scala, lib, Scala, Scala library. I think that's what we need to do. And then I'm gonna do main. And it couldn't find class main. I'm not quite sure why. Okay, and it's very strange. Class not found main. Is it because I also have to do something CP here? Right. I forgot how to use Java. Does anybody remember? So I need to do class path to the jar, and I also wanna use class path like here in the same folder. So let me try to do that. Java use. Okay, so I have to separate them. Yeah, I haven't programmed in JVM language for quite some time. Thank you so much. Yeah. Anna Leon the first. Thank you. So yeah, so this is essentially how we're gonna do that. Sorry, I'm a zoomer using Maven Gradle. Well, I mean, there's nothing wrong with that. It's just you know less about underlying things, right? So there's only that. And I wonder, yeah, is there such thing as Scala Home? Is there such thing as Scala Home? Similar to Java Home? Where is Scala home on Ubuntu? You should be able to set your Scala home. Okay, so the reason why I want to set the Scala home is that then later in my makefile scripts it will be easier to refer to the Scala library later. I thought Ant and Gradle are for Zoomers. No, Ant is for boomers, by the way. Ant is very old. Gradle is for Zoomers and Maven is for millennials. Right, so yeah, that's quite important. Again, Ant, boomer. Maven, millennial. Gradle, Zoomer. There we go. That's the gradation here. Cool. So, by the way, give me a second. I want to actually, you know, refill my water. I didn't actually pour any water to my bottle before the stream because it didn't finish filtering, so I'm gonna just quickly go to the kitchen. Yo, what's up? I'm back. Back. How everyone is doing? What about who uses none? I don't know. They're outside of this category of people. Proto-boomer. Yeah. Alright, so yeah. What I want to do, I want to go to my Scala environment, right, Scala environment, and I also gonna set the Scala home. So we're gonna do export Scala home, and we're gonna set it to be fair, we're gonna set it precisely to that. It's gonna be opt Scala blah 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 blah, right? Like this. And let's remove everything, and this one is gonna be Scala home. So let me do src one more time for opt Scala environment, right? And if I do echo Scala home, it will give me this entire stuff. Okay, cool. So now we're ready to write a makefile. How about that? We're gonna be building Scala with makefile. Oh. Alright. Isn't that epic? Isn't that epic? I think it's pretty good, epic. Yeah. Cool. So what are we trying to build here? I think we're trying to build a main class. And it depends on main Scala. One build system to rule them all, exactly. So we're gonna do Scala, main Scala. Simple as that. So then we're gonna do test, which depends on main class. And what it does, it just runs cp Scala home /lib Scala library jar, and also the current thing, and just tries to run the main. So, and this entire thing is gonna be a phony one. So let's see how it's gonna work. And it didn't work. Nice. Probably because oh, it's not Kala. Wait, Kala? Is that because I have to do it like that? Or do I have to do it like that? Okay, it always opt. Oh, probably because I have to start Emacs from within the development environment. Yeah, that's probably why. And also, yeah, Scala C there. Thank you so much. This has to be Scala C. All right. Cool. Hello world. But maybe I can just use Scala. Can I just do Scala on Scala, main Scala? Holy shit, it takes so much time. It was probably a bad idea. I think we're not gonna do that. I think it's a bad idea to do that. Okay. Cool. As far as I know, it's similar to Kotlin. You can just do equals, and I think that will work as well. Well, this is not fast, to be fair. Like, what the fuck? Yeah, this is definitely faster. Light speed language. Yeah. Holy shit. Okay. Am I regretting this decision? Well, I mean, the decision has been made. There's nothing I can do about that. Yeah. Okay, we're doing that then. That means we're doing that. Even though I might regret using this language. We're doing it anyway. So the first thing I want to do, I want to, you know, learn how to parse command line arguments. But I mean, it's kind of obvious in Scala, right? Because here you go. Here you have command line arguments. And what's fun is that I think you can do something like for each. Can you do for each? Oh, by the way, you also have Scala docs. Do you have any thoughts on Dotty? No. Yeah, so Scala actually has a pretty goddamn good API documentation. So let's take a look at the current one. It's pretty goddamn amazing. So you have a search, and for example, I want to find some information about arrays, and you have two buttons here, by the way, O and C. And O means you want to take a look at the static methods of this class, and C means you want to take a look at the class method of this class. And the reason it's O because it's a companion object, right? It's a companion object, and all the static methods are located there. So we can take a look at you know, static methods. Nothing special here. And apply, by the way, is a very interesting method. That means you can use that object as a function, right? So the fact that you can do the following thing, let's just wait a little bit until the Scala loads up. I know it's a very fast language. I think it's getting slower, and I think it's up. Anyway, the fact that you can do this thing is because array is an object with overloaded apply method. So that's why you can use it as a function here. So let me take a look. What consumes so much resources? Is that JVM? I think the Oracle JVM is doing some really weird stuff, but okay. Okay, anyways, so what I want you to look up in the array specifically. Let's take a look at the class. Does it have for each? I don't remember if any of them have for each or something like each. Yeah, they do have for each, and I can do something like for each print line, and this is how I can print all of the arguments here. Let's try to do that. I didn't really want to do that, but okay. Is your first set Scala dev should go? God damn it! Like, unfortunately, not everybody will understand that reference, but recently we read an amazing article about programming languages. So I'm not gonna lie, it was one of the most amazing articles that I've ever read. Okay, and the problem is that I now have to re-enter the development environments one more time. So I have to re-enter Java, I have to re-enter Scala, and then go back to AOC 17 Scala. There we go. Yeah. So, and what's funny is that it didn't really print anything because arguments didn't contain anything. But what if we try to provide some arguments? For example, sample files, right? Because we're definitely going to have samples there, don't we? Jiang, hello, welcome. We're programming in the fastest language on planet Earth. You want to see the compilation speed of that language? You want to see the compilation speed? I'm gonna show you the compilation speed. Holy fuck, you're gonna be amazed. So faster, yeah, it is faster than Kotlin, believe it or not. But I need to first prepare a makefile. Inputs, and I don't remember how to, you know, add arguments to the running thingy, but I'm gonna try to do it like that. Okay. Oh, okay. It worked relatively fast because it didn't recompile anything. Okay, so if I try to do -b, look at the compilation time. It's a hello world, by the way. This is a hello world. Yeah. Amazing. Absolutely amazing. So this is going to be the real challenge, not the problem itself, but the fact that we have to work with this language. Okay, so, and now, I suppose I don't have to do it like this. Back to days where compiling meant time for a coffee break. Exactly. So that means a dash is not necessary, apparently. I didn't know that, but yeah. So we can have something like this, and now we can have something like solve file, and we can have file path, which is a string, and it's not going to do anything here, and we can do solve file. Right. So, but I like how like functional it is. Like it's a very functional language. Imagine giving 2 thumbs down for C++ because it doesn't have a GC. Anyway, so print ln. I don't remember how you do string interpolation in Scala. Can you just do it like that? I think you have to have interpolators. Scala string interpolation. God damn, I think at some point we need to like read that article on the stream, because this article is fucking legendary. Holy shit, I really loved it. Input file, file path, and I think this is how we have to do that. Yeah, so basically if you want to have like a string interpolation, you have to do it like that. And you know what's funny is that you can have several string like interpolators. This is a function defined somewhere in a standard library. You can have your own string interpolators that will interpret these things differently. For example, some database libraries would define their own SQLite SQL string interpolator, and they will enable you with doing things like x equal x, and these string interpolators will automatically escape any special characters in this variable, so they're gonna safely like insert it there. So Scala enables you with, you know, developing your own DSLs and stuff like that. It's actually quite cool. But again, it's a very slow language, so 1.5 star. So input file is that, and okay, so let's see if it's gonna work or not. If trolling very smart made money out of his trolling. Yeah, I think, yeah, if he was trolling, this is extremely fucking smart, because he managed to trigger so many people, god damn. And also a lot of people actually liked his article on the I don't understand. Okay. So, I think we're ready to take a look at the problem we're trying to solve. So we're solving the day 17. Okay. Oh my god. Okay. Conway cubes. Conway cubes. As your flight slowly drifts through the sky, the elves at the mythical information bureau at the North Pole contact you. They'd like some help debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites. The experimental energy source is based on a cutting-edge technology, a set of Conway cubes contained in a pocket dimension. Holy shit, is that some sort of a SCP shit? Yeah. When you hear it's having problems, you can't help but agree to take... By the way, is there any SCP that is a Santa Claus? Has anyone made Santa Claus into SCP? I'm pretty sure there should be something like that. Like, there has to be something like that. But I mean, I'm not really like, don't know too much details about SCP. Yeah, there is something, okay. 4040, okay. That's very cool. scatter. Would you look at that? Sinkhole has been. Okay, I'm gonna read that about that a little bit later. Thank you so much. Okay, when you hear it's having problems, you can't help but agree to take a look. The pocket dimension contains an infinite three-dimensional grid. Okay, at every integer three-dimensional coordinate, there exists a single cube which is either active or inactive. Is that three-dimensional conveys game of life? Is that what it is? Is that what it is? Okay. In the initial state of the pocket dimension, almost all cubes start inactive. The only exception to this is a small flat region of cubes, your puzzle input. The cubes in this region start at the specified active or inactive state. The energy source then proceeds to boot up by executing 6 cycles. Each cube only ever considers its neighbors, only of the 26 other cubes. 26 other cubes. So you have 9 plus 9 plus 9 plus 8. Okay, it is actually in fact 26. So because the first layer is going to be 9, the second layer is going to be 8 because the center is U, and the third layer is going to be 9 again, and it's 26. I don't know how to count them, sorry, I had to use calculator for that. So any of the 26 other cubes coordinates differ by at most 1. Any of the 26 other cubes where any of their coordinates differ by at most 1. For example, given the cube the neighbor. Okay, I see. During a cycle, all cubes simultaneously change their state according to the following rules. If the cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains active, otherwise the cube becomes inactive. If the cube is inactive but exactly 3 of its neighbors are active, the cube becomes active, otherwise the cube remains inactive. Okay, this is literally conveys game of life, but on a 3D. The engineers responsible for this experimental energy source would like you to simulate the pocket dimension and determine what the configuration of the cube should be at the end of the 6-cycle boot process. For example, consider the following initial state. Even though the pocket dimension is 3-dimensional, the initial state represents a small 2-dimensional slice of it. In particular, this initial state defines 3 by 3 by 1 of the 3-dimensional space. It's a single layer, right? Simulating few cycles from this initial state produces the following configuration where the result of each cycle is shown layer by layer at each given z coordinate. Okay, before 1 cycle, so then you have more layers here. Actually, you can go to the negative 1. Okay, so all right. Okay, after 3 cycles and keeps going. After the full 6-cycle boot process completes, 112 cubes are left in the active state. Starting with your given initial configuration, simulate 6 cycles. How many cubes are left in the active state after the 6th? Really? Seriously? Really? Is that the problem? I mean, I would imagine that maybe the second part is going to be a little bit more interesting, but this is literally conveys game of life in 3D, which I never implemented, by the way, so it could be interesting to implement. And also you have to take into account the situation that you're going to go into, like a negative or something. Okay. Alrighty. So I'm gonna add this thing into the sample, right? We're gonna add this thing into the sample, and we're gonna start a slow and tedious process of implementing this thing, right? Because I can already tell that this is gonna be very slow and tedious, because, yeah. As already people mentioned, it requires a lot of maintenance work. Let's take a look at the puzzle input. The puzzle input... Okay, so that means the second part is gonna be pretty... pretty interesting, I would say. Okay. Dead Bod Jiang is okay. So this is going to be an input. We're not going to go into that yet, but yeah. So I suppose it starts at Z0, right? So it starts at Z0. Oh, why did I make it so small? So this is a Z0. So what's going to be the best way to do that? And it's infinite as well, right? So spoilers, second part is not much more interesting. Okay, thank you so much for the spoilers. I really appreciate you. I really appreciate all of the spoilers. All right. Ban him. Nah, I'm not gonna ban him. So what I'm thinking is that how we're gonna represent this entire stuff? Are we gonna represent them as 3x3, like, you know, three-dimensional array, or maybe we're gonna represent it as a you know, sequence of cells, right? Sequence of cells where we're gonna have like a cell. I think, yeah. What's cool is that in can you have data classes? I forgot how to do data classes in Scala. Data class. To be fair, we don't really need any of this stuff because you can just do type cell, alright, and you can do something like integer, 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 right? So, and yeah. And essentially, to be fair, your dimension can be something like dimension. Is this how we spell dimension? Is that with T? I think it's S, right? And dimension could be just a set of cells, right? It could be a set of cells and dimension. Okay, I don't know what the hell is going on with me. My brain doesn't really work properly today for some reason. It's really strange. Yeah, I really apologize for that. So, and our dimension could be that, and we can just iterate through the whole file and fill it up with, you know, like this. So, because it will simplify implementing like negative stuff, but maybe we can pre-allocate like a huge three-dimensional array. I don't know what's gonna be better. Symptom is brain fogginess. I don't know what that means. I don't know what that means. Okay, so how can we read the file in Scala? A read file. Read entire file. So maybe we can take a look at the Scala docs. Maybe they can give us something. Yeah, I should actually keep them open all the time because they're very useful. Because they are very useful. Here's the API, the current one. So do we have something like file? Okay, there is a from file, right? There is a source from file. Okay, so can we just try to use that to read the file? Maybe I just need to make a cup of tea. That could be it. Maybe I just need to make a cup of tea. Source from file, and I'm gonna do a sample txt. And not found source. Maybe I have to do it like this, from file. It's Scala IO. Import Scala IO. And by the way, instead of like the star here, you have to use underscore here. And this is how we import. And I should be able to read from the file. Okay, so it gives me an iterator, but can I then convert it to a string? Is that the thing I can do? It still gives me... Okay, that's cool. Alright, it gives me some sort of like a buffered source, right? Cool. What can I do with the buffered source? Can I... drop file, filter, flatten. You can get lines. Okay, so I can try to get lines. Oh shit. I pressed enter and it didn't work. Auto... Okay. It still gives me this thing. So iterator... Oh, you can make string out of it. Display all elements of this iterator in a string using a separator string. Okay, that's very interesting. So maybe I can do make string without providing anything here. And there you go. So this is how I can read the whole file. Yeah, so source from file and then make string, but in this particular case I can do get lines, right? Get lines and then, I don't know, supply the empty argument list explicitly to invoke method get lines. Okay, sure. And then I can try to map all of that by doing something like make string. And it didn't really work, but maybe... Can I do list? Yeah. So, and then to list. There we go. So as you can see, I managed to read the file and then get the list of the lines. And this is how I can work with that. This is actually pretty convenient, isn't it? But you not necessarily have to convert that to lists, right? Because that iterator is sort of like a lazy list, right? You can just program like in Haskell where you have infinite lazy lists and you can stack operations on top of them and they're not going to be evaluated until you try to access those lists. So yeah, it really feels like programming in Haskell. By the way, Scala at the time, maybe it still is, was a huge outlet for Haskell fans. People at the time who wanted to work as a Haskell developers, they couldn't find a job as a Haskell developers because nobody used it in production or anything. So when Scala came in, a lot of Haskellers just jump on it because they finally had an opportunity programming like in Haskell, but also have a job that they get paid for. So maybe these days it's not that big of a problem because I heard like there's a lot of jobs for Haskell, but I don't know. I'm out of the loop of the software industry anyway, so now they're all Java devs. Yeah, so this is how the industry tricked a lot of Haskellers into the enterprise Java. So yeah, that was the plan all along. By the way, that was the plan all along. By the way, hello, mCourse94, welcome. How are you doing? So that's a pretty clever plan, by the way. Now they become Kotlin devs, but it's difficult to program on Kotlin like in Haskell. It's way easier in Scala. The edit streams to debate them, yeah, exactly. Okay, so we know how to... I'm slowly starting to remember how to work with this language, which is kind of cool. I like that. Is there any way to enumerate or something? So if I have an iterator, right? So line iterator. It's kind of similar to Rust, like it also has different sorts of iterators and whatnot. Iterator. So get lines, where's get lines? It gives me collector iterator. So, and is there any way to enumerate that? Enumerate. Probably not. Index. What about index? So it's an indexed of to indexed. Okay, so you can actually do just indexed. I see. So maybe I can do something like map and then to indexed sequence, right? And then to list. Oh, it just converts it to a vector. That's why it's an index. Okay, whatever. All right, let's actually move all of that to our code. Import Scala.io. So import Scala.io. Source from file. This is going to be file path, and yeah, get lines. Map. Make string. I'm not even sure if we need to make string because I can just do get lines and I still get an iterator of strings, and if I do toList, it should be just... Yeah, I think make string here is completely redundant, so I can just get lines. And so I'm thinking what I want to do about that. I want to map this entire thing to get a character of some sort. I'm thinking... Because, yeah, so if I have a string like this, right, can I, for example, filter equal to this thing? Yeah, I can do that, but on top of that I want to do an index thing. Yeah, so I guess the easiest way is gonna be just iterating them, and maybe yeah, I want to turn them into tuples of some sort, but I'm not sure how convenient it would be. Maybe I can just do that and toList, and then it's gonna be lines. I think I'm trying to make it too functional, so I'm gonna actually not do that. So then I'm gonna iterate each individual line. Right, within each individual line I will try to iterate each individual character. Right, each individual character. And I need to know their coordinates, right? I need to know their coordinates. I need to know their coordinates. But how can I know? Okay, Scala for each index. So how do you do that? Get index of current element and for each. I think it's quite important. Zipped. Okay. Excuse me? You can do zip with index. Okay, that's actually cool. So if you have something like this, did I forget to put? Yeah, I forgot to put this thing. Okay, thank you for reminding me about the command. Yeah. Okay. What I was doing, I was trying to make the thing indexed. Yeah, this is what I was working on. I was trying to make the thing indexed. Zip to list. Zip with index. Yeah, this is what I was trying to achieve all along. I forgot the separation. It's like enumerate in Rust, but in Scala it's zip with index. So again, every language calls these things differently, and you have to just memorize all of them. Yeah, exactly. Exactly. You can call functions. Yes, you can, as far as I know. It actually depends on the function. Auto application is deprecated. So yeah, it depends on the function. Some functions can be called, some functions cannot be called. But generally, yeah. Alright, so maybe because of that I can do something like get lines, zip with index, and this is where I get the index. And for example, if I have a string hello, can I zip with index a string? I can. And that gives me a vector of these things. Okay, that's actually pretty cool. Alright, so I zip with index. And then I'm gonna map this entire thing, and in here, and as far as I know, I think you can do something like this, where, or I don't quite remember, I think something like this was also okay, that would be lambda as well. Where you would have like a single line, but you also have this as a line, so this one is going to be probably y, so we have y and line. And what we want to turn this into, by the way, we want to flat map it. So the interesting thing about this task is that space expands on every step. Yes, I know that. Okay, so in line, actually, I want to zip this thing with index one more time, but then I want to filter, not flitter, but filter only the things, right, so I forgot where's the index. Index is the last thing, so that means this is the index, where the second element of the tuple again, whereas the second element of the tuple is equal to this thing, so that gives me that stuff. After that I want to map this thing and extract only the first element, basically the index, and zip it with actually, yeah, can I do something like this, where this is gonna be x, and I'm gonna turn it into xy, and just return it like that. So will something like that compile? I wonder, actually. This is like a huge expression, but maybe it will work properly. We'll see, we'll see. So, and then can I print line it? I think I should be able to. Yeah. So we read from file, get lines, zip with index, that gives us that, where we have line and y. Then we take each individual element there, zip it with index again, filter it by the second one, and map access like that. And we'll get a list of the coordinates like that. We'll get a list of the coordinates like that. And to be fair, you can straight up also set z to 0. And that's going to be the coordinates of all of the things that set to active. So, and let me try to compile that and see if it's going to compile or not. Probably not going to compile. We'll see about that. Are my Scala reflexes? No, my Scala reflexes are not really that great. The expected type requires a one argument function accepting two tuple. Okay, so let me learn about Scala lambdas, because I forgot the syntax for Scala lambdas. Lambda expressions. How do you do lambda expressions in Scala? So we do it like that with multiple parameters. Okay, so here are multiple parameters. Okay, so but what about, yeah, you can do that without thing. But I forgot, can you do something like that? Maybe you cannot. Maybe you cannot. Maybe it has to be something like this. And I want to pattern match the tuple. That's what I want to do. I want to pattern match the tuple. But I cannot quite remember argument types. Tuples cannot be directly destructed in method function. Either create a single parameter accepting the tuple 1 or consider a pattern matching case. That's very interesting. Okay, so they ask me to pattern match. So I think it's okay to pattern match. We can use partial functions in Scala. Partial functions, if I remember correctly them. Yeah, so it's actually amazing. So what the fuck? Like I just didn't realize how good it is. Wait a fucking second. Yeah, can we just stop and appreciate that this like error message actually like explained the shit to me? Holy fuck, this is so rare. Okay, so partial function. I want to take a look at the syntax. Yeah, that's the syntax. So essentially, what I'll have to do, of course, I'll get a sneeze. Okay, excuse me. Oh, nice. Okay. He's crying. This language is so beautiful. This error message is so beautiful. Oh my god. I'm crying. Okay, so it didn't really work. Probably because... Yeah... Case... Okay. So maybe I don't have to do this thing. This is really strange. Like, I'm super confused at what's going on. So maybe I have to do it like that. Is that what I have to do? Oh, I think I'm confused, chat. What the hell is going on? So, well, we need the second one, and in that case, oh wait. Oh yeah, okay, I see. That's why it didn't do anything properly. Okay, that explains it. I'm sorry. Thank you, by the way, everyone who said bless you. Thank you. So is it gonna work? Please tell me that it's gonna work. I think it's gonna work. I think it's doing the things. Okay, and it returned the iterator. Nice. I really like that. I really like when the things return the iterator. So now we'll have to turn it into list. And wait another half of an hour. This is really bad. And it's empty. Nice. I'm so happy. That it turned out to be empty. What? So we have a sample here, and a sample contains that, and to be fair, I really didn't expect that it will do something like this. Okay, what if I just get the lines? Will it give me what I wanted? Wait trials for an empty list, yeah, exactly. So okay, I get okay, so this is what I wanted. So now if I zip with index, will you give me what I want? You should be able to give me what I want. So the problem is probably somewhere here. The problem is probably somewhere here. Yeah. So here we pattern match this thing. So here's the line. Zip with index. So then map it. And I think maybe I have to turn it into a list. Yeah, I think that's the case, because this entire thing returns a vector, right? If you take a string hello and you zip with index, right? You zip with index, it's a vector. And then if you map some additional stuff, for example, by taking the second element of the vector, right? It's still going to be a vector, but you cannot flat map one container to another one. So they have to match their types, and I don't really know why it compiled in that case though. It's perfect for work though. You can go for yeah, exactly. That's why everyone loves Scala in enterprise. I mean, and also in machine learning. Underscore 2 is the index for the character. No, it is not. It's an index for a tuple. Imagine that you have a tuple, right? So this is a tuple. And how do you get the first element of the tuple? You do it like that. The second element of the tuple, you do it like that. And what's interesting is that underscore 1 or 2 is a lambda that extracts first or second element out of the tuple. So imagine that you have a list, right? So 1, 2, 3, 4, right? So here's the list. Zip with index, right? And you want to extract the indices, so you do map and you create a lambda that extracts the second element of the tuple. That's how it works. All right. So, so it still doesn't really work. It's really strange. Okay, let's try to map this thing instead then and see what's gonna happen. Yes, exactly. But it's a function. You have to consider this as a function. Okay, let me try to do this thing then. Still gives me that. Okay. There's something wrong with filter. There's something wrong with filter and I don't understand what exactly. What is wrong with filter? All right. Okay. Oh, okay. I found it. I just used the wrong one. I should have actually, yeah. It does that on a different order. There we go. And what's interesting is that if I do flat map now, yeah, now I need to take the second element here, and I won't be able to do that. I think I will have to do something like case. And then I'm gonna do flat map. Flat map is, by the way, bind in terms of like Haskell or yeah, something like this. You cannot do it like that, unfortunately. So let's call it P, and I'm gonna just take P second one then. It's gonna be X, hopefully. There we go. So this is how I managed to get all of the coordinates of active cells. Right. So essentially, with a single expression, I transformed this, right, this, into this. And it's a really single expression, just a sequence of maps and stuff like that. So I read from file, get lines, and so on and so forth, and now I have this as a list, and I'm pretty sure you should be able to actually convert it to a set, right? So we can try to convert it to a set and see how it goes. Yeah, let's convert it to a set. There we go, we have a hash set. So we essentially have a set of coordinates, which we can query and stuff like that. Yep. Is that even a good idea? Is that even a good idea, or is it better to just have a three-dimensional thing? But to be fair, this thing like expands over time. It expands over time, so and it also can be negative. Like all of these things can be negative because it's an infinite thing. So I think it would be better to keep it as a set for now, and then we'll see how it's gonna go. So the only problem is here is that, well, to be fair, if you're using like a sparse representation for a game of life, you only need to look for empty things that have neighbors and stuff like that, right? So yeah, okay, that's actually pretty cool. And let's continue. I maybe don't even need to like type cell, but maybe we'll need it in the future if I will have functions that do things. All right, so this is going to be that, and so let's call this thing pocket, right? So this is a pocket dimension representation, like of the initial state of the pocket dimension. And I think I want to introduce another function called part1, which accepts a pocket dimension, right? And it's a set of cells, right? And by the way, yeah, undefined in Scala is actually triple question mark. And this is, by the way, one of the reasons why sometimes when I program in other languages, I still do that, because I have these reflexes from the Scala times. So, and yeah, we can do something like part1. And we can also return something like, we're supposed to return an integer, right? If I remember correctly, we're supposed to return an integer. Yeah, so let's return int. And that's going to be our final solution. And after that, I can do something like print ln part1, right? It's going to be like this. I think I can do stuff like the no? Oh yeah, because this has to be like a string interpolator. Yeah, there we go. So my favorite way of interpolating strings is that I can put like actual expressions here. It's so convenient in my opinion. All right. So, and maybe for now I'm going to just do 69 just to check if everything's correct here. And it didn't work because I couldn't call it for some not found value part. Oh, because it's a part1. Oh my god, I'm so dumb. I'm sorry, chat. Pocket. Right, so here's the pocket. In here, to be fair, we can just do something like very simple. Pocket length. Do 69 to check if everything is okay. It's just a random number. It's like foo or something. Shit, that takes long to compile. Yes, it does take long to compile, but it is what it is. That's the challenge. It's a part of the challenge. So, I don't remember. Is that the length or size or something? Let me take a look at the set. So here's the set traits. Traits, by the way, are not the same as traits in Rust. They are interfaces. Right. Traits in Rust are more of a type classes, and there is no built-in type classes in Scala, but you can emulate them. Is it a length? Is it a size? Is it a count? It is a well, I mean, size. Yes, it is size. Cool. So, and here we can try to return the size now. Yeah. So, does it look like Kotlin so far? What do you guys think? Does it look like Kotlin? It should look like Kotlin. Except these parts. I think it's a little bit weird for Kotlin to have this kind of stuff. but yeah. And okay, so we have five active things. We have 5 active things. Yep, Coquelin. Yep, Coquelin. Yeah. So here is the thing. Here is the thing. Now we can try to iterate through all of the elements here, right? Through all of the elements here, and generate a new set. To be fair, yeah. Next generation. So we're gonna have a pocket that accepts set and returns a set of cells. So this is basically what we're gonna have, and this thing is not implemented yet, but maybe, yeah, so it's not implemented yet. Essentially, we need to do next on a pocket dimension like 6 times. I wonder if there's like a more functional way to do that. That would be kind of cool. Because in Haskell you have something like iterate, right? Where you can take initial state, a function, and like indefinitely apply that function over and over again, right? I wish like Haskell would load up a little bit faster, but yeah, I already have a lot of slow things here. So I can iterate, I can apply +1 on a 0, and I can take 10 elements out of it, and that generates me a sequence from 0 to 10. And so you can use this kind of thing to, you know, move forward several generations. And I'm thinking, is there something like that in Scala? If Scala had something like that, that would be actually extremely useful. Let's find out. Iterate. Maybe it's even called like iterate. It's probably not. Stream iterate. Does it even have stream iterate? We don't even have streams. Is that a thing in Java, to be fair? Like, do you know anything about that? Is that a string in Java? I mean, think. I think I need to look at the objects. It's hard to write your own iterate, though, in case it doesn't have it in std. Excuse me. Okay. Yes, there is. Okay. Okay. An infinite stream that repeatedly applies a given function to start value. Would you look at that? Isn't that amazing? I think you can do the same shit in Scala. So we're gonna do stream, iterate. So initial value is gonna be 0, and is it carried? Okay, it is carried. So that means I can do something like +1, and then I can take 10 elements out of it, and I think I need to force it into a list, and there we go. You can literally do the same in Scala. You can literally do the same in Scala. Well, stream in package is deprecated since use lazy list instead of stream. Okay, so they call it lazy list. Sure, I can use it like that if you want me to. That's very interesting. So they used to call it stream, now it's called lazy list. Yeah, and what's funny is that you have to force them manually, right? So you have to convert it to list first to actually get anything. Oh my god, this brings back so many memories. Where are my 20s? Okay. So yeah, we can do something like that. We can essentially do a lazy list. Iterate. We start with a pocket, and then we apply function next. We apply function next, and we take like, I don't know, 6 of them, and that allows us to iterate over these things. It allows us to iterate over these things, and we can even try to print all of that, maybe, like to list, and just print and see how it evolves and stuff like that. So you see. But this is not the most interesting part in my opinion, so in here we'll probably have to do something like 69 just to return something, or maybe, yeah, so let's actually put question marks here because it's not finished yet. So the most interesting thing here is to implement pocket, right? Is to implement pocket. And we can easily like check active cells, right? We can easily check active cells because literally what you have to do, you just have to like flat map the active cells, right? You need to flat map active cells. And in here we can have XYZ, right? And then just check the rule. But then you also have to check inactive cells, right? You also have to check inactive cells. And you don't really need to check all of the inactive cells. You need to check only those that are really close to the active ones, because those are going to be the only ones that you know, going to be affected. But you also have to keep track of which empty cells you already checked, right? Which empty cells you already checked, and that could be a little bit painful to do. So I wonder if I'll be able to solve that with a single like expression or something. With a single expression, we'll see about that. We'll see about that, but before we go into that, I think I want to make a cup of tea. So does anyone have any questions while I make a cup of tea? So yeah. Do you guys like Scala so far? Is that a good language? Yeah, there we go. So here is the result of several like iterations, but we haven't implemented the iteration function yet, right? But it collected it to a list. Like I really like you can program in like pretty much you like programming in Haskell. That's what it feels like. It's like programming in Haskell. But compile is very fucking slow, yeah. Mark. Well, I guess it's something that got translated. Yeah, so this is the name to which triple question mark got translated to after compilation to JVM bytecode, right? It's Kotlin, but even slower, actually epic. Yeah, I would say that maybe Scala's strong part is not its speed, but its intellectual masturbation. You can intellectually masturbate in Scala actually quite hard, and I would say even harder than in Haskell. Yeah, it's a weird dialect of Haskell. Yes, exactly. That's what it is. It's a really weird dialect of Haskell. What do you think about $$ being the wrong way around in Haskell? That's a very strange question. So why do you think it's wrong? Then we have any other questions? Pipes are easier to understand. Probably. For some people. For some people it might not be. It depends. It depends on the person. What's funny, Jiang, is that I did exactly what you did for a long time when I only started programming in Haskell. Seriously, I would always like implement my own pipe operator like that and put it in all of my Haskell projects. And at some point I stopped caring about it. Yeah. So it's kind of interesting that you're going through the same route as I did. So all right, let me quickly go to kitchen. I'm gonna turn on the kettle and then I'm gonna quickly go back because the kettle is in the kitchen. So really sorry. Hello. How's it going? How's it going? How's it going? I guess ready. Do you have a girlfriend? No. So this is how we're gonna iterate through that. I'm just not sure how we are supposed to handle empty rules, if you know what I mean. If the cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains. Okay, so let's actually implement something more simple. Neighbors, right? Let's implement neighbors. pocket set cell, and we're gonna return integer. So essentially, we're gonna accept the cell here, right? And we're gonna just count neighbors for that specific cell. For that specific cell. Is that a UK corner spelling of neighbors? Okay, I'm gonna use UK corner if you want me to. Sure, I don't mind. Now what we're gonna do, we need to, I want to use the same trick I used for two-dimensional one. For two-dimensional one I just use you know, nested loop, right, to generate the coordinates, but it relies on the ranges. Do we have ranges in Scala? Literal not found. Wait a second. Can I do 0 from... I remember that I... Huh. Okay, I remember that there was some ranges in Scala. How to use range in Scala? Okay, let's find out. Where's my cell phone? Ah, that... Oh, I know! Oh shit, this is actually super clever. You know what it is? 2 is a method of integer. Seriously. Yes, so to and until are methods of integers. So because Scala is object oriented, right? And you can actually do something like this and it will also work. It will also do the same thing. It's just you can call methods like this. You don't have to call them with dot or anything like that. They're optional. And it's very like, it's very small talkish, I would even say. Right, and here it is. And can I do something like -1 up until 1? I think I can. And then if I turn it into a list, yeah, this is basically the list that I've got. And because of that, I can use the for loop here. And by the way, for loops in Scala they're more like list comprehensions rather than like for loops. So here I'm iterating access, right? And I think, can I just yield access? But it actually depends on the monitor. Yeah, you can do that. Print ln x. Can I do it like that? Oh shit, I can. So, and I don't quite remember, but I think you could do something like this as well. To 1 and just, you know, print x and y. Ah, there you go. So they work more like list comprehensions, and you can do z. -1 to 1, and then you can generate all of the possible coordinates, and here are all of your neighbors that you need to check except 0, 0, 0, right? They're not really neighbors, they are diffs between you and your neighbors, so you need to filter out 0, 0, 0 specifically. Yeah, so should be pretty straightforward. But how can I generate this into a list? I forgot how to do that. Scala list comprehension. It's really cool. Yes, it is really cool. So for is simultaneously for and list comprehension, like slightly depending on the context. I don't quite remember how to do that. Yeah, you have to use yield. Yeah. So you have to use yield to generate this stuff, and that will give you not a valid. Cool. In terms of language design, I think Scala was ahead of its time and still kind of is, because it's extremely ergonomic and all of these pieces, they really fit together in really interesting ways. Like I kind of really like it. But in terms of implementation and you know, the fact that it's a JVM thingy, anyway. So I think you can even check things here, like you can even have conditions in that thing, like if x not equal 0 and y not equal 0 and z not equal 0, maybe I have to actually put it like this. Nah, it doesn't really work that well, because yeah, this is what I'm talking about. If you shouldn't put this thing here. I don't remember. Space. Oh shit, yeah, I'm sorry. I made a very stupid mistake, and now I'm trying to find something that doesn't exist. Yeah. And I think it has to be or. I think it has to be or. There we go. So now it doesn't include any of this stuff. And yeah, so we can use this thing to just generate all of this stuff. We can just generate all of this stuff. And as far as I know, you can do things, you can even format things like that. You don't need a semicolon if you like separate them by lines. So here is your generator, right? And in here, you just yield this thing and it gives you like a list or vector or whatever you want. Right, so this is how you do list comprehension in Scala. With GraalVM, you could compile it to native code ahead of time. Sounds like a pretty huge rabbit hole to go into just to research how to set all of that up, so I'm not going to do that, sorry. Actually superior to Kotlin. So, Funcchi, now you understand why I was not so like impressed by Kotlin. Like I was, because I worked with this thing 8 years ago. And I wrote like an actual commercial projects with this thing. So, you think you can impress me with Kotlin? Yeah. But I can actually get the job with Kotlin. Yeah, true. That's true. So, but the thing here is, now what I want to do here is I want to filter even more. I think we can go even deeper. For example, if pocket contains XYZ, something like this. Right, and yeah, it will automatically generate the coordinates. It will filter out the coordinates that are impossible, and then we can check if they're contained in the pocket dimension, and we can yield them. And the last thing that will be needs to be done here is just to take the length of this entire thing. Right, the length of this entire thing. So, but this is not really correct, because this is not really x and y. These are dx, dy, and dz. Dx, dy, dz. And interestingly enough, here I want to pattern match this entire thing x, y, z, and I think I should be able to do this kind of stuff. So is this magic shit? I'm getting angry as a Kotlin dev. Why are you getting angry? I don't understand. We don't even know if this entire shit is gonna compile. So I know that part up until here does compile. I'm not sure if this will compile, and I'm not quite sure how to do the rest of this stuff. And to be fair, maybe I can actually sidetrack away slightly from pure functional way and do something like var result. Look at that. So essentially in Scala you have two kinds of things, like val and var, right? And val is basically immutable. It has a built-in support for immutability, by the way. Did you guys know that? Built-in support for immutability. And var is a mutable one. And what's cool about the Emacs extension is that it highlights them with red for some reason. I don't know why. I like that, but I kind of like it. So, and I think here what I can do essentially is just result +1 and then just return the result. So without generating any lists or anything like that, it could be just a for loop. To be fair, it's not that different from a regular for loop if you ask me. It's just, yeah. Anyways, Let me try some stuff. Let's see if this entire stuff compiles. I'm gonna try to compile main class. I'm not gonna try to run it because obviously it's gonna fail. Let's see if it's gonna at least compile. And it doesn't even compile because you cannot pattern match things like that. I think you cannot pattern match the arguments in the cell here. But I mean, you can always do something like that. So you can have cell, and then you can do val xyz cell, and I think that should be enough. And alright, expected by this thing phone. Do I have to do like these things? Do I have to still use this stuff? I feel like I have to use still use semicolons. A legal start of a simple pattern. Okay. So maybe I have to do this. A legal start of a simple pattern. Okay, you cannot easily do all this stuff. Maybe. So let's remove the last semicolon and see if it's something like this will work. Hopefully. Unneeded. That's a very nice image. Chat is compiled. There we go, and it kind of worked, and I think I should be able to now do this thing. I'm a linter, not compiler. There we go. There we go. So list comprehension. To be fair, it's not that different if you just had like 3 nested for loops and then 2 ifs. It's just a little bit more flat. Yeah, I think it's a little bit more flat because in C, for example, you would have like 3 nested loops here, then 2 nested conditions here. But maybe not nested, you can actually put it into a single one, but it's gonna like have like a very long one. But it's just syntactically it's nice, generally. Anyways, so this is how we can, you know, count the neighbors. And I wonder if I can easily test all of that out. That would be actually pretty cool if I could easily test that out. Can I use main? I don't think I can easily do that. Main. Scala cp dot. Is it possible to do something like that? If it is, it's gonna be very, very pog. Not gonna lie. Not gonna lie. Alright, so after that, I'm gonna try to do neighbors and... oh yeah, it has to be you. Oh shit! Okay, missing. That means I can use that. So 0, 0, 0, right? And then I can have an empty set. And it will tell me that, yeah, you have... That's actually pretty cool. You can recompile this thing and you can do Scala cp dot, and it will be able to find that class because it's in class path. So we can load up and actually test things out. Alright, so maybe it would make sense to extract this entire thing into the method so I can use it in repo. That's actually pretty cool. Def pocket from file, so you have to provide file path. And it's gonna be string, and you'll get a set of cells, right? And we can go down there, and just put it like that. Pocket from file, file path, and pocket from file. I'm gonna put it like that here. How about that? Let's recompile all of this. Maybe we'll have to restart the REPL. We'll see about that. Yep. Like I'm very like unproductive with this language. Yeah, but I mean I'm trying to remember things with, and it's really not trivial language, if you ask me. So main. What was that? Pocket from file. Yeah, pocket from file. Can it auto? I think it's trying to auto. Yeah, I think it can autocomplete things, sort of, maybe, I don't know. So if I try to load up something like sample.txt, it should give me this sample.txt. Okay, cool. And then I can do main neighbors 000, boom, and it should give me the neighbors. There we go. 000 has only a single neighbor, and we can check it out. Is that true? Is that true that 00 has a single neighbor? Yes, it is actually true. Look at that. We can take a look at 110. 110 should have actually 5 neighbors, right? If you put something like 110, it should have 5. Yeah, there we go. So it actually computes them correctly. Cool. So that's pretty poog. That's pretty poog. And now we need to implement this thing. So this has to be like a pocket. So if it's already active, to be fair, what I'm thinking about is So essentially, we don't need to check all of the possible cells. We only need to check active cells and neighbors of the cells, neighbors of the active cells, right? Because anything outside of the neighbors of the active cells is not going to be affected by anything. I have an epic idea. What if we create a function that returns us the neighbors of the cell, essentially, not counts the neighbors of the cells, by the way, but literally returns the neighbors of the cell. So neighbor coordinates, rather. I solved it the same exact way. I'm the god coder. I didn't solve it yet, so what are you talking about? So I need to call it something, but the idea is going to be similar to this one. So you're going to get the list of the cells which are neighbors, right? And essentially how I do that, you just use that, right? And here you essentially just yield x plus dx, y plus dy, z plus dz. Yeah. So, and then we can iterate through all of the active and just turn them into their neighbors and still collect them into the set, because set will contain only unique numbers, so we won't have to worry about duplicates. So that's kind of the point of using a set here. And then we can implement neighbors in terms of that one. Okay, so I'm gonna call it nbors. This one is gonna be count active nbors, right? And essentially here what we're gonna have is xyz nbors cell pocket. Let's call it nbor. Nbor. I'm going to do that. Okay, so we're iterating through all of the neighbors, and if pocket contains that neighbors, that means it's active, so we include it into this entire thing. As a matter of fact, we can do that a little bit more poggish by doing something like this. Filter pocket contains, and I think that will work as well. And that will let us to get rid of this thing. So you see, I generate all the neighbors and I filter only the ones that are contained in the pocket, and then I can just do size, right? And this is a lambda, right? Well, it's supposed to be. I'm not sure if like it will work, but generally, yeah, I really like how nice all of that looks. I don't know. I'm kind of enjoying like the intellectual masturbation of this entire thing. I don't know why. It's kind of stupid. It's kind of stupid. Maybe because maybe it's some sort of a nostalgia. It's definitely nostalgia. Yes, yes. It's definitely nostalgia. Alright, let's try to compile this thing and see if it's gonna work or not. It's like Haskell, but I can actually read it. Yeah, it is true. It is like Haskell, but it's readable. But I mean, you already know Haskell, so like it's not like it matters or anything. So I really don't like how I cannot destructurize the thing. Can I destructurize the arguments by doing something like this? Is that a thing we can do? I think there should be a way to do something like that, because I remember it was possible. It kind of makes me sad that you cannot destructurize them like that, and the only thing you're left with is having bindings like this. But I mean, I guess I can live with that. So, found indexed sequence, but required list. Okay. Can I just do sequence then? Okay, so we're gonna actually return more generic thing. Like, we're gonna try to return more generic thing. And to be fair, we don't really need pocket here, if you think about that. Yeah, pocket is not even used here anyway, so we can do something like this. And get rid of that. So we do cells, then check if it's active or not. And I think that's gonna go. I mean, Koei, hello, hello. I haven't. Did I say hello to you? I don't remember. But hello. American English doesn't have useless uglot. I don't know what you mean. Yeah, I like American accent more. Me too. Alrighty. Are you gonna do a pog thing? Okay, so we're gonna have neighbors for 0, 0, 0. There we go. And it has to be main. Right, there we go. It has to be main. So here are all the neighbors, and then we can count active neighbors, and so on and so forth. If I do something like 5, 5, I just want to see if it will return everything appropriately. Yeah. Okay. So how we're gonna implement the part 1? How we're gonna implement the part 1? So pocket contains only active things. So what we want to do here, we want to flat map it to. Well, to be fair, we can just experiment with this thing. So I'm gonna do pocket from file, and it's gonna be a sample txt. So there you go. And then I'm gonna flat map it to all of the neighbors. So that gives me the area that we need to consider. Yeah, there you go. So essentially pocket contains only the active ones, and we flat map it with neighbors, essentially like bind it, and it essentially extends the area to the neighbors as well. And now we include active and inactive that can be affected by active. So the next step we'll have to do, we'll have to map this entire thing, checking whether the thing is active or not, and applying the rules that are described here. You see what I mean? Yeah, so it's actually pretty cool. I would solve I would solve this problem similarly in Haskell. So yeah. So it actually quite neat to solve this problem in functional programming way, because it just allows you to think about this like high abstractions and stuff like that. By the way, feel free to try to implement something like that in Haskell. I think it will really fit Haskell. Anyway, so we're gonna do flat map to neighbors, right? So flat map to neighbors, and then I'm gonna just do map, I suppose. Do we need to do map? Well, it depends. Oh, this one is very interesting. So maybe it doesn't have to be mapped, because some of them has to be filtered. Yeah. Huh. Okay, so I think in this particular case we have to use something like filter then. Right, yeah, it has to be something like filter. Not flitter, filter. And here we're gonna do case, and this is our like cell. Okay, and there are two situations that we need to consider. Two situations, whether the cell active or not. If a pocket contains the cell, that means we are active. That means we're active. Otherwise, we're inactive. Right. Otherwise, we are inactive. Cool. We are active, and we might as well also take a look at the neighbors here. Right. So, what kind of neighbors we have? Let's put it like this: n and neighbors for the cell and for the pocket that we're currently mapping. There we go. So, and if we are active and n is within 2 and 3, we want to stay active, right? We want to stay active. So that thing is going to become true. So that means it's not going to get filtered out. The next thing, if you are inactive and exactly 3 neighbors, you become active, otherwise inactive. So that means n is going to equal 3. So there we go. That's it. That's the implementation of next. Believe it or not, that's the implementation of next. Okay. So let's see if it's going to compile. Missing n from nbors. Do I? Yeah. Also, there's something. So did I forget how to do if conditions? Do I have to do it like that? Maybe I have to do it like that. I don't quite remember, to be fair. Don't quite remember. Okay, and yeah, count active neighbors. So that's what exactly we need to do. We need to count active neighbors. So in this way, I really like the solution with set, because you don't have to worry about negative numbers, infinite numbers, or anything like that. You just, let it grow, let it grow, let it grow, and it works, hopefully. So let's try to play with that in the, in the repo and see how it goes. See how it goes. I'm enjoying what I'm doing for some reason. So, okay, pocket from file sample.txt. All right, and then we can do main next, and let's see what's going to be the next. Cool, and it's not that much, but it keeps extending and stuff like that. So what I want to do is learn. So we need to perform six steps, right? We need to perform 6 steps. How many cubes are left inactive after the 6th cycle? So we can generate the list, but now I have to take this 6th element. After iterate, you have a stream. In the stream itself, do you have something like at, maybe def at, let's see, or maybe get. Because I don't really want to materialize everything. I want to add nth, or maybe it's called nth. Nth. I didn't find nth, to be fair, but maybe we can find nth somewhere here. Do you have nth anywhere? Okay, let's use Google. Scala stream nth element. How to delete all nth elements? I don't really want to delete. I want to get. Hello, God Killer David. Welcome to the stream. Take every nth element. How do I get the nth element of a sequence? So it's kind of funny how Google shows me Java 8 when I actually Googling for Scala. So it kind of shows that the language is dead, fortunately. Okay, so we can use it like that then. All right. So if I try to do something like this, right? So lazy list iterate. So and this is the initial thing, and we're going to use main next, right? So this is what it gives us, right? It gives us this thing, and I'm going to take. Actually, I want to take 7 of them, right? I want to take 7 of them. And can I just take the second element here? I cannot, but maybe I can just do it something like this. Okay, I can just take the second element. Or maybe that means I don't even have to take, right? Okay, so I have an infinite list. I have an infinite list. Here's the first element. Again, like this. OS, System, NixOS, or Debian. Hello, Akira, Life, Leo. Hello, hello. Is that a question? I don't understand the question. And that means I can just take the 7th one. The reason why I need to take the 7th one, or maybe not, maybe I can take the 6th one because it actually, yeah, okay. And after that I can just take the size of it. So that's going to be the solution. And there we go. This is the correct answer for the sample. 112, and it works. It took way too much time that it should have, like, for me to implement that. But I kind of went on a nostalgia trip for some reason. Anyway, so this is how you would implement a part 1, essentially by doing something like this. Lazy list, iterate starting from pocket, and then next. Wait for the part 2. So the part 2 is going to be even more. Okay, I see. Iterate, and then I guess yeah. So I can just do 6. There we go. So that should be the solution. The intellect got masturbated well. You're goddamn right. Okay. Found the set. Wait, what did I do? I provided pocket. And then I have to take the size. Yeah, then I have to take the size. What's up, potato passing by? Do you need a hair command or something? I don't know. Alrighty. Cool. So now we're gonna include sample.txt and input.txt, and let me just try to run this entire thing. And I think that's the final answer that we'll have to pass in here. 313, and let's see if it's gonna first try. How about that? First try, motherfucker, in Scala. And actually very elegant solution. Would you look at that? Very elegant solution. Very Haskellish, I would even say. Yeah. First try got cooler. I really like this. Goddamn. Haven't shaved head years ago, no regrets, so much less hassle. Exactly, I could not agree more. So I'm thinking, for how long? It's almost a week, or maybe more than a week, and I still have not regret anything. Which feels like a brain massage with a happy end. Yeah, I only wish it compiled a little bit faster. In a dream last night, I pointed in my head and asked the barber for the great reset. Yeah. So how many years of hair growth has gone? I don't know, around 10, I think. It wasn't worth it anyway. I don't shave it smooth, but buzz it down. I kind of prefer like shaving it smooth, so I think I need to shave it once again. I mean, after the stream probably. Do you have a long hair, BTSY, by the way? Alright, so let's take a look at the second part. Oh shit. Are you serious? Since the pandemic. Oh, I see. Alright. Let me just prepare. For some reason, your simulated results don't match what experimental energy source engineers expected. Apparently, the pocket dimension actually has 4. Fuck you. I'm gonna go pee. Okay. I'm gonna just go pee. I don't need to read anything else, okay? I just don't need to read anything else. Thank you very much. Okay. So, all right. So let's make a small break. You guys have fun. Hello. Hello everyone. Do I need to read any further, or do I just go ahead and extend my solution to just 4 dimensions? Do I need... No, okay, so I don't need to... Okay, so we can just try to do that. Let's actually do a challenge. Let's just try to blindly extend it to 4 dimensions and see if it's gonna work. That's the problem. How many cubes are left after active state after the 6th state? Okay. So at least I know the answer to this one and stuff like that, but anyway. So what's funny is that now our cells is kind of useless. So maybe I'm gonna just introduce like this thing. So cell is gonna become cell 3D, and then we're gonna have cell 2D and so on and so forth. To be fair, can we abstract that away? So essentially I just need to implement like second version of all of these functions. Well, almost. I mean, for example here I don't really need to implement a second version, like count active neighbors, right? Count active neighbors, because you can just make a generic out of that, right? So if you make it generic, so it's gonna just work like this, so without any problem. Right, and we can test it out. Today was one of the last C lessons group before Christmas. I gave them this thing which I hacked together in 15 minutes. What is that? Is that a -1 in... Oh shit! For fuck's sake. Okay. So did you ask them for anything, or did you just give them that and said go, or what? Nice one. I just gave them that. Okay, so maybe we're gonna take a look at that a little bit later. Did you give that to Dennis? I think Dennis would like this kind of stuff. I might take a look at that after the advent code. If you remind me about it. No, but I will. Okay, that's one. Okay, I want to see what that problem does if you run it. Be careful. I mean. Oh shit! And goddamn, you just cannot do that. You have to have a second version of it. You really have to have a second version of it, because neighbors. Yeah, I see. So okay, so let's just go ahead and do that then. So this is going to be use OOP. We can try. I can just have like a part 1. Yeah. So object part 1, and this is where we can move all of that. Yeah. I think that's how we're gonna do that. So here's a part 1. And essentially, yeah. So in the part 1, actually, we have to parse them slightly different, so it has to be file path. What the fuck, I was joking. It's too late. You think it's a mother flipping joke? I think it's a mother flipping joke. OOP is not a mother flipping joke. Anyway. So here's the pocket. We don't need to do that anymore. So part is going to be file path, part 1. So in here we have part 1, pocket from file. Okay, there's a pocket from file, and again the file path, and then part 1 next, and this is just the sixth part. So, and then for the part 2, we're gonna just copy paste part 1 and change the dimensions of the cell and go to the compilation errors. This is how we're gonna do that. Yeah, so in here I'm using objects as just namespaces. I'm just using them as namespaces, not like real objects or anything like that. It's not like I like OP or anything. Okay. So mismatch, okay, 6, and this has to be size, I think. God damn it. Function, stop function. No. Alright, it seemed to be worked. Maybe I can, whatever. So now what's funny is that the part 2 is gonna be just copy pasting this thing and maybe replacing 1 with 2, like this. Boom. There we go. We might as well actually. Yeah. Anyway, so I'm gonna copy paste this entire shite and just put it here, right, like this. So this is a part 1. This is gonna be part 2. And the only change I'm gonna make here is I'm gonna add additional dimension here. That's it. Nothing else, and I'm gonna just let the compiler do the work. Please, Mr. Compiler, tell me where I have to make my changes. Here are the places where I have to make the changes. So first I need to do this. So we're gonna use W as the 4th dimension, right? So this is gonna be W minus 1, and or dW not equal 0, and basically W plus dW. And that's it, believe it or not. So we don't even have to modify this. I didn't think we have to modify that. So I suppose here we have to just add additional 0. We just have to add additional 0 for the 4th dimension. And in here, nothing is pretty much changed. Okay, so if I try to compile this thing now, is it gonna compile? It feels like it's gonna compile. It feels like it's gonna compile first try. Oh shit, it's compiled first try. So, but I don't really use it anywhere. So what I'm gonna do here is I'm gonna just do part 2. Backdoor catchy PLS, yeah, exactly. I would be really careful. Because Plots is an epic C hacker, so be careful with running C code for him. And I already got the correct answer from the sample, because I remember in the sample it was 484. Nice problem, by the way. Seriously? Literally copy paste it. Nice job. Are you fucking serious? 10 pages of explanation, by the way. 10 pages of explanation. You can literally ignore this entire shit and just... I wish there was like an easy way to abstract that away somehow. So how can we abstract it away? I don't know. Because there is a lot of duplicate code. We literally have to do now over-engineer it. Don't want to over-engineer it. Okay. So from what I heard, the next problem is going to be my last one. right? So, but I'm not gonna solve it now, right? So the next problem is gonna be 8th one, but I'm actually lagging behind, so intentionally, so people have a time to solve them first, and yeah. Oh, we solved it. Oh, you guys solved it. You didn't like it, but you solved it anyway. Right, okay. So because I heard people like really not happy about 18th, I thought it's super difficult. But we'll see how it goes. But I'm not gonna solve it right now because I'm gonna, you know, wait until majority of people solve it. As in, I went away for a while. Oh, okay. Blinked and missed the solution. Oh, we saw it. Yeah. So essentially what I did, I just copy-pasted my entire code into a separate namespace, and I just updated cell to be first dimensional one, and that's it. And I solved it. It's so dumb. Oh my god. It's the dumbest thing I've ever seen. Anyway. Pretty trash problem. Okay. I wouldn't say it's trash. It's really lazy, right? Maybe the author got tired or something, but yeah. And look how many classes Scala generates, right? It generates so many classes. It usually generates like 2 classes per a single object, which is kind of strange, but I mean, it's just Scala being Scala. So anyway, let's actually commit this solution. So I'm gonna do git ignore, and I want to git ignore all of the classes. Right? We're gonna git ignore all of the classes. And I'm gonna introduce a README where we're gonna explain how to use all of this stuff. Okay, so day 17, and we're gonna point to the 17th day here. Solution in Scala. And what's the official website of Scala? I think it is located somewhere here. New haircut, yes, it is new haircut. Hello, Safakoi. Check out the hair command. So here's the thing. God damn, like, to be fair, I used to program in Scala a lot on the streams, like 4 years ago, roughly, I think. When I was not even affiliate on Twitch. And maybe some people who watch me since those times can remember that. But it brings back so many memories, like, I'm programming in Scala with like 5 viewers and stuff like that. Yeah, such a nostalgia. Maybe I have to. Maybe I should like revive some of my Scala projects or something. But to be fair, compilation times are extremely bad. Compilation times are just like killing me. Okay, so I actually extended format of my readmes. Now I also specify the versions of the languages that I use, like the implementations. Tested on. And I think it's quite important to provide a version of the JVM. So we're gonna have a version of the JVM. What's the next language? I don't know. That's kind of the point. I usually decide on the language right before the stream. I don't prepare anything, seriously. So we're gonna have Java. So this is the JVM I'm using, and in terms of Scala, what's gonna be the version? Oh yeah, okay, so this is the Scala. By the way, can we consider Dotty a separate language? I think the first stream I watched was actually Snitch. Oh, nice. It's pretty old, but not as old as Scala. I think the only person who remembers Scala is probably EverX80, but he's like very old friend. Holy fuck. He's been watching me since I wasn't even streaming on Twitch yet. Like it's, yeah. He probably remembers Scala. What's the font are you using? I think we have, yeah, there we go. Here's the font. Rider, there we go. EverX Synapi. Sen API. So this is that, and expected result. So what's going to be expected result? Let's actually see. I think I'm going to go to the compilation. The expected result is this. Right. I also put it here just for the comparison, because maybe on your machine is going to be slightly different. Right, and quick start. Okay. Muscle memory. Haha. All right. Install. So I think you need to set up JVM as well. the similar way you set it up for the Java thing. Install JDK. Okay, so this is very similar thing, like install JDK, but this time you don't need Java C. And make sure Java is available in path and everything. Cool. Install Scala. So we can download it like this. Right, install Scala. And make sure install Scala. And make sure Scala C is available in path. Maybe I'm gonna split them. Make sure Scala C is available in path. Set up Scala home environment variable. Okay, point variable to Scala distribution. And to be fair, I think I want to give the link specifically to one of these things, to the tarball, right? Because we're not like we're not using Scala in a very conventional way, because the conventional way of using Scala is either using IntelliJ IDEA or SBT. But since I have a potato laptop, I cannot do that, so I just installed Scala directly. SDK man. So type in distribution, thank you. By the way, hello Nafli. Hello. Distribution, point Scala home environment, make sure Scala, and then just do make. So install JDK, Java is available in path, install Scala, Scala home environment, Scala C available path, there we go. So this is the whole thing, this is the whole setup. SBT, it's CBT, but for S. God damn it, you got me. Alright, so that's the whole thing. Yeah. Very funny, goddamn. I can't believe you've done this. So add day 17 solution. And yeah, let's just push that out into the repo. And you can find the source code for all of the solutions right here, right now. Look at that. Look at that repo. Look at that beautiful, beautiful repo. Isn't that amazing? So we have 17 different solutions and 17 absolutely different languages. Seriously. And all of them are full solutions so far. I'm not sure about the 18th problem, but yeah. Yeah. So yeah. Pretty cool. And here's my environment in which I am testing all that, and yeah, a lot of different languages. So check it out if you want to learn something new. I don't know if you can learn something new. Available. Where did I make a mistake? I don't know. I'm sorry. Yeah. Oh, I know what you mean, but I'm too lazy to fix it. I'm sorry. But maybe I should fix it because. Yeah. Right. Okay. Available. Thank you so much. Thank you so much, Turkey1. So it's typo. Just merge the PR. Is there a PR? God damn it. I cannot merge it. Even if I wanted to, like, I really would like to merge it, but I can't. Let's try to resolve it. Okay. So, and what do we do here? I never used this tool, by the way. How do you use it? It feels like they have a different length. R. Oh, okay. So that means I can do the following thing. So install JDK and make sure Java is available in path. And yeah. Cool. That's convenient, actually. Cool. Nice. And what's the difference here? And div shows that we replaced R with is. Nice, nice, nice. Epic. So I never used this tool. It's actually pretty convenient. Looks good to me. Thank you for your contribution. Even though in the contribution file it says no pull requests, but I mean this kind of pull requests are welcome. Yeah. Nice. So the problem is officially solved. So we can continue doing other things. Right, and specifically today I actually had plans to program in Haskell a little bit. So let me close everything, and yeah, if you're into functional programming, and I would assume you are because you joined the Scala stream, and Scala developers usually are into functional programming, and yeah. The tree. You want to take a look at the C. Okay, let's do a little bit of C first, and then okay. So it's gonna be all right. So let's solve the C puzzle. Okay. C puzzle. So I'm changing the title of the stream, and we're gonna take a look at the C puzzle that Hodson gave to his students. And after that, we're gonna continue doing Haskell. Hopefully, we'll see. But the problem is that, well, it's not the problem. Let's take a look at that. So, third party, make dir here Hodson tree. Okay, here Hodson tree. Can I get this entire thing? Can I? This is not how I get it. So the where does? Didn't I open the tree? Could you please send the link yet again? I'm Pepega. Or maybe I'm not Pepega. We have 5 raiders from Dandy MacG. Oh my god. Okay, so well, okay, here it is. Thank you so much for your support. Thank you for the raid, and welcome to our epic stream. So here it is. So let's try to do a Clang format on this thing. A Clang format. Do we even have a Clang format? Yep. Is it gonna do a thing? Okay, so did it modify it? I think it just only... Yeah, it didn't modify it, so we'll have to like save it to T. Clang format C. Let's take a look at what it does. Okay. So that's really strange, but I mean, so you basically forward declared some of the functions that are important, right? So it's a little bit more convenient to, so we don't have to include anything. Okay, so if you have 3 arguments, you expect that. If you don't have 3 arguments, you return h is going to become 32. All right. Okay. Okay, so we don't really need any of this stuff. Right, we don't need any of this stuff. We can just remove it. Okay, so you don't really need to provide any arguments, right? So it's basically, you can provide width, right? You can provide width of some sort. And okay, so this entire thing is just to customize the width, but it's called h for some reason. But okay, so then you multiply it by 3 and you divide it by 4, right? So because one bit shift to the right is going to be divided by 2, another one is going to be divided by 2. Should be mind such exactly. That's like the first thing that I've noticed that is weird, right? So because yeah. Thank you, Danny Marjim. Good night. Alrighty, so then we check whether I is divisible by 1, but it's not really how you do that, but yeah, it's just... No, it's not divisibility. Okay, so... Alright. What is n, by the way? No, n is that. Okay. To be fair, so far I don't see anything dangerous, so it's not a dangerous code per se, right? So we can just try to run it, and let's see if it's ever gonna, you know, finish. It's definitely gonna finish here, and it's definitely gonna finish here. So yeah, I don't see anything super super unsafe here. So we can just try to run it, because yeah, let's just go ahead and run it. But I'm gonna compile specifically the Clang version. He just solved the halting problem. Yes. I mean, it's kind of obvious that it's not gonna, you know, hang or anything, right? Because you have this thing, like you can even calculate this thing, I suppose. So you have 32, you multiply it by 3, and then you shift it by 2. So this is how many iterations you're gonna have here. You don't have any go-tos or any modifications of h. You really don't modify h, so this loop will 100% finish, right? So this loop will 100% finish. This one also gonna 100% finish, so, and 32 just shifted to 2 bytes. It's gonna be 8 iterations, nothing special, right? So at least I don't see anything, right? So we can try to run it, unless he's actually debating us into something. And he's probably obscuring like a lot of these separations. Maybe we should... what are we doing here? We've got a pretty interesting source code from Herr Hotzenplotz that he gave to his students. Right, so it looks like this. It looks like a tree. Right, it looks like a tree. And it's a C code, right? It's obviously C code, but do you dare to compile it and run it on your machine? Do you fucking dare to do that? What will it do? So hard to guess. yes, I dare. Okay, so let's actually try to build it with GCC, and let's see if GCC is gonna crash or sigfault. Okay, it didn't. There we go. That's actually pretty cool. So it just draws the tree. You know what would be cooler? You know what would be cooler? If it was a Quine. So if it would actually print itself, but I mean it's probably difficult to make it Quine, but it's too much effort, but yeah. Yeah. Alright, that's a pretty cool one. It's a pretty cool one. The scariest part about this thing is that whether you can run it or not, but first you need to deobfuscate it or at least Clang format it and just go through this thing. And it's actually pretty safe code. I didn't see anything special. Why are you bold? Why are you bold? Yeah, because of the hair. Thank you so much, everyone. All right, so cool. We cracked the puzzle, so we know that it's safe. And let's continue to doing some Haskell. Have you ever heard of Kotlin, all capital letters? No. As a programming language, I mean. Oh yeah, it's also like an island in like near St. Petersburg, I think. Kotlin Island, I think. Is it not? Yeah, it's an island. Is a Russian island located near the head of the Gulf of Finland, west of St. Petersburg. Yeah. So here it is. Think. Yeah. Is that what it? No, where is it? I don't know. I've never been to St. Petersburg, so I don't know where it is. But yeah, Kotlin is an island near St. Petersburg. So I heard it as, yeah, even I heard about it as a programming language. Cool. So yeah, today I had a plan to continue working on my spam filter in Haskell. How about that? So I started to work on it last week, I want you to continue working on it. So here it is. It uses a very simple naive Bayes classifier. The reason why I'm using it is because I never studied anything like that in university, so I decided to practice. And surprisingly, it works quite well. It really works quite well. You just like use the naive Bayes formula, and it just works out and it classifies everything correctly. We do not approve of racist vocabulary, and maybe we can also do the follower mod for like, let's say 1 hour, or maybe 30 minutes. I think 30 minutes is gonna be okay. All right, so let's continue. So let's take a look at the current state of this thing. So yeah. So essentially the idea is that we have a set of emails and this set is labeled. We know which emails are spam and which emails are ham. And by the way, in the terminology of spam filters, ham is basically something that is not a spam. Like ham is not spam, which is a funny pun. Yeah, ham is delicious. Naive Bayes works surprisingly well for NLP tasks. Yeah, I heard about that, but I never actually did any NLP. Maybe we're gonna do NLP in the future. There's a lot of topics in machine learning that I want to visit at some point. MLP tasks. What is MLP tasks? Okay, so My Little Pony. Oh, I remember that one. A spam filter in Haskell. Machine learning. What do you guys think? Is that a good title? Like a spam filter in Haskell, machine learning. I think it's actually pretty good. I think it works quite well. My Little Pony. Yeah. Okay, and oh yeah, it has to be square brackets. Yeah, I completely forgot about that. Thank you. Let's try it one more time. Yeah, I think it's good. Machine learning, spam filter in Haskell. Oh my god, very intriguing. Yes, I know. Thank you so much. All right, so let's go to Vetchina. And for those who doesn't know, Vetchina is basically ham in Russian. Yes, so the spam filter called ham, but in Russian. It's very funny, I know. Very funny. So maybe I want to fetch the latest changes. I think I tried to clean up this entire repo off screen, and one of the things I introduced it's a German spam filter, I suppose. And let's merge this thing. Yeah, there we go. I actually put like the entire data there, or the entire training data here. So I actually swapped out the tar, like the tar GZ with 7-zip to actually save on more space. And I included the whole enron data set. The whole enron dataset is actually pretty big. It contains like several thousands of emails. Labeled emails was what's important. So they already labeled as spam and ham. So they're already ready for training the models, which is actually quite cool. I like the word toast. Toast in Russian is pretty unique. What do you mean? I'm sorry, I don't understand. But anyway. So the data set that we're using, we're taking it from here. Here's the website from where we took the spam data set. So if you want to use it for your machine learning, you can take it from here. Machine learning in Haskell, isn't machine learning a Python thing? Well, we're trying to challenge that assumption. That's what Haskell, that's what Sodding channel is all about. We're challenging all of these assumptions. I just got Dennis hooked with the tree. So what is he trying to do? Is he trying to like, just run it first? Or is he trying to, deobfuscate it? machine learning, and where is the TensorFlow and PyTorch? Like, why do you need a TensorFlow and PyTorch, right? If you have a Haskell lists, you have that. Why do you need anything else? I mean, come on. Anyways. So yeah, again, you can, if you want to use this data set, you can find it here, and I included the whole data set there. But since it's pretty big, it's all actually zipped up, so we have a special script to prepare the data. So the thing it does, it unpacks all of the archives and splits everything into ham and spam, into several folders, and also on top of that, it splits the whole data set into the training set and validation set, right? So basically we can train on one big set, and then we can validate if our model is like, you know, acts as expected on a validation set that it never saw before. So this bash script basically prepares all of that. And yeah, essentially what you have to do first, you have to go into the data folder and just run prepare data, and it will just unpack everything and split everything accordingly, and then you can just use that data. Yep. So while we're waiting for the data, so let's see how we can, what we can improve here. So the main problem with the current implementation is that it's extremely slow. It is in fact extremely slow, and this is because we are using a very inefficient bag of words. So we just have a bag of words, and this is just a map from a word and how frequently, and in its frequency, how many times we saw it either in a ham set or a spam set. And we use that bag of word to calculate the probabilities. Right, so we have a word probability, we give it a word, we take word, we take bag of words, and we calculate the probabilities. And the problem is that we do that every time we need a probability, which is really dumb. So essentially I need to basically first, before trying to classify anything, my bow is pretty efficient. By bow I mean a bag of words. So essentially what we need to do here, we need to pre-process bag of words into a map from a word to its probability based on its frequency, so we don't have to recalculate it all the time. Yeah, you see what I mean? And this is one of the, like, this is the, like, a low-hanging fruit of optimization that we can do on this thing. And it probably will, you know, speed up things dramatically. So yeah, I think we prepared the data. So we prepared the data. So we have two sets here. So here's the training set. On that set, we're gonna train our model. So if we take a look at the set, we have ham. So basically messages that are not spam. And there's a lot of them. As a matter of fact, I think we can take a look at some. So there's 16,000 emails that we know for sure are not spam. 16,000. And we take a look at some of them, I suppose. We can take a look at this one and see if it's really not a spam. To be fair, to me, it looks like a spam. Just a couple of additional thoughts. The cost estimate is... Oh yeah, it is not a spam, so it's some sort of like a conversation. Okay. So, and we can take a look at this, some of the spams. Right, we can take a look at some of the spams. And how many spams emails do we have? So let's actually count them. 17,000. Imagine training model on that, on the whole set. So the current implementation is going to be extremely slow, actually. It won't be able to easily process like and use this entire set. It's going to be very slow. But we're about to change that. We're about to change that. Okay, so this is a spam, I suppose. I hope there's nothing TOS and friendly in the spams. I really hope so. But yeah. So right now, what do we have? We just have hello world here, and this is kind of cool. So essentially, what you need to do, Cabal version 2 REPL. You just go to the REPL, and you will have a very handy function called classify folder. So first of all, you will need to grab the spam model, right? And training a spam model is going to be pretty long process, right? So we're going to do it like that, spam model, and I'm going to just grab the spam model like this. Okay, I think it's training. It's actually training. Maybe not. It's actually trained really fast. But anyway, so, and now we can try to classify a specific folder. So classify a folder with this model, data, spam, let's actually use validation, spam, and I think that's it. So, and it starts classifying things. And look how slow it is. So it grabbed this email and it's trying to determine the probability of it being a spam and the probability of it being a ham. Look how much time it takes. And there's hundreds of these emails there. So that's the main problem we're trying to solve today. Can we make this thing go faster? And I think we can, because the reason why it's so slow is because I'm Pepega. Well, I mean, I was just exploring how to implement this entire thing, but yeah. Throw more threads at it. No, we don't really need to do that. Essentially, the reason why it's so slow is just repeats computations that could have been cached. It just constantly repeats those computations, but they could have been cached. Like, why do we do that? We don't need to parallelize anything. We just need to stop doing things that are not needed anymore. Yeah. It's probably never going to finish, actually. It's probably never going to finish because it was slow on thousands of emails, like 2,000 or 3,000 emails, but now we have 17 and 16,000 of emails, so it's going to be even slower. It's never going to probably finish, so we're not going to even bother. So I'm going to just stop it and, you know, start working on it. Haskell. Yes, exactly. This is Haskell. Cache computations. Nice emote. Is that a functor penetration? Yes, it is functor penetration. Nice. DP in Haskell was a pain, to be honest. Okay, Xiang, I'm gonna tell you a secret. I'm actually making a video about DP in Haskell. Like YouTube video. You know, like in good old times. And it's based on the 10th problem in Advent of Code. I'm showing you how you can do efficient and very convenient DP for that specific problem. I already recorded it. I'm currently editing it. So yeah, soon it's going to be out. So I'm going to show you, essentially in that video, I'm going to show you how to do that DP in Advent of Code. Not properly, but I'm going to just show one way to do that, like a more interesting way to do that. Not like without maps, arrays, or any of that stuff. You can actually do that, and it's actually very interesting. So yeah. Without maps, I mean without like data map. That's what I mean. Because there's operation map, right? There's an operation map and there's a data map, right? Without data map and without data array, right? So without these things, how to do that? Actually, without any data structure. And it's actually as fast as, you know, Rust implementation, actually. Very intriguing. To be fair, maybe I'm not gonna tell you that much new, but yeah, I will try to get it to get that video out as soon as possible. Besides, it's almost like edited to the completion, so like it's half edited. It's gonna be around like 20-30 minutes. No data structures, but I mean there will be one data structure, but I mean there's nothing special there. Okay, so the main function for calculating probability is word probability, right? So this is word probability. It takes a word and bag of words, and based on the bag of words, it calculates the probability of that word. But here's the thing, we don't change a bag of words during classification phase. The only time we're changing bag of words is during training phase. So that means we can pre-cache these entire operations in a separate map, word probability, and speed up the whole process of classification dramatically. Right. So I need another thing here. So here's the bag of words. and I need another type, foo, but I don't know how to call it yet, which is similar to bag of words. So foo to map, which is essentially just maps a word to a frequency, right? To be fair, we could have just used bag of word and parameterize it with just a, right? Just parameterize it with a, and then we could have like type aliases. You type like, and here we're gonna have frequency with it, which is an integer, and then we can have probability, which is a double, right? And essentially, if you have bag of words, you can parameterize it with frequency. So bag of words, but it stores frequency, and then you can have bag of words, which is probability, and that's gonna be the main reasons. Maybe I'm gonna actually call it prob. Yeah, so fric and prob. I think that's quite cool. Okay. So maybe before I continue, I'm gonna make a cup of tea. I think I do need a cup of tea. While I'm making a cup of tea, Shat, do you have any questions or do you have anything to say to me while I'm making a cup of tea? So let's make a small break. So I still have, this is really strange, like sometimes I have, oh yeah. It's kind of strange, to be fair, that people are not using like Haskell or like purely like these kind of languages in machine learning too often. Droka87, thank you so much for 2 months of Prime subscription. Thank you, and welcome to Epic Machine Learning Club. About that. Are you using Blender to edit your YouTube videos? Yes, I do still use Blender for editing videos. I think it's like the best option on Linux so far. It's not the best generally, but on Linux, yeah. Whenever I go to Papyrus, ask him whether he understood monads. Were you trying to explain monads to Aiguduk yesterday? Okay. To be fair, like in my opinion, there's no need to explain monads to anyone, because every programmer understands monads like intuitively. They just don't know that it's called monads. Like literally there's no reason to explain that. It's just the fact that we have a name for this concept draws too much attention to something that is not that important, in my opinion. I mean, it's just whatever. So yeah. Now I understand them better, that's for sure. Let's see. Iterator. Well, iterator could be one of the monads. So basically, what is common between such things as list, iterator, option, future, and so on and so forth? So consider like these types. What's common between them? And that's monad essentially, yeah. So it's a very oversimplified way. Like, I mean, a lot of people would disagree with me, but some people would say that the thing that is common between them is a functor, right? You can say that, but I mean, whatever. It doesn't really matter in my opinion. So anyway, so I'm gonna go make a cup of tea. Not a cup of tea, but I'm gonna go turn on the kettle, and then I'm gonna go back, and we can continue. All right. So. Oh, fucking coming. Hello. How everyone's doing? Welcome back to me. So yeah, he came. So let's actually do a compiler-assisted refactoring. So I made a change to this type, and now if I try to compile it, it's gonna fail miserably. What is the context of this quote? Nobody knows. It's lost to history. So semi-group. Okay, this one is interesting. I don't quite remember. But the thing is... Oh shit, I think specifically, yeah, bow for words has to be a semi-group and monoid. Yeah, bow for words, but I'm not sure if I can easily do that. I think this kind of stuff will require an extension. I do think so. Yeah, please tell me that. Yeah, flexible instances. So it will require flexible instances, but I think for this particular case we can do that. It actually edited twice because I mean it's a Haskell mode. Compiler assisted refactoring, yeah. Okay, so we have a spam model. For now, I'm gonna say that the spam model accepts like stores frequencies because I'm just doing this small thingy. Bow from folder, so it's gonna be frequency. GHC is so fast, is it? Well, I mean it's faster than Scala for sure. Okay, summary bow, it takes frequency. So what does it do? I don't quite remember. So I think I can just do the following. I cannot do that. Yeah. Compared to Scala, this feels like a dream. Yeah, it's true. Miranda is faster. I should try Miranda at some point. Sounds like very... Does Miranda feel exactly like Haskell? Okay, so that was actually quite easy. You know, I'm gonna create a separate branch where I'm gonna do the speed up process. I'm gonna call it speed up, and hopefully here, in this branch, we will make this thing go brrr, go brrr. Okay, go. Really, it lacks type classes. That makes it less Haskell-y. Yeah. Well, yeah, I can see that. Type classes make Haskell so much more useful, to be fair. Anyways. Alright. Parameterize bow. JCI is so epic, not gonna lie. Yeah, it's extremely freaking good. I think it's the best repo among all of the languages I've tried. Yeah. I like how it defines a workflow for you, right? Because you can just do, like if you have a file, right, main.hs, you can start editing that file quite easily. And then when you exit, it automatically will already show that multiple times, but I really like that the workflow, the development workflow is embedded into the repo. Like it's just so nice. Yeah. Miranda has the same workflow. Pretty cool. And kind of like the thing about Cabal, for example, it feels like Cabal breaks that workflow, and it feels like Cabal was developed completely by different people who, like, the different from who developed the original Haskell is just so weird. I don't know. Anyways, so now we have a bow that is parameterized by frequencies, and we need to introduce a bow that is parameterized by probabilities. So first of all, we need some sort of function that would take a bow with frequencies and return a bow with probabilities, right? Because that's essentially what we need to do here. And we can probably implement this function in terms of word probability, but not necessarily. Hello, Count Ren, welcome to the stream. Can I ask you what company you work for? You can ask it, but will I answer? That's a good question. I think I forgot to update the project command. Today we continue to develop spam filter in Haskell. Source code is gonna, yeah, I work for KGB. Since I'm Russian, I work for, yeah. Cezin Vitvetchina. No, I don't work for FSB. I work for KGB specifically. They are a different department. They're a different department. KGB is more secret department because every official version is that KGB does not exist, right? So anyway, we need a function that would convert bow of frequencies to a bow of probabilities. And how should we call this function? Let's call it freq to prob. Is that a good name for this thing? Is that a good name for it? My kettle is ready, by the way, so I'm gonna quickly go to kitchen, I'm gonna quickly brew out my tea and go back. Okay, hello. FSB Zoomers, yeah. KGB is for boomers and FSB is for Zoomers, yes. Very funny. I'm just writing something on a real typewriter to make it look. Are you typing out your tree? Please tell me you're actually typing out your tree. That would be actually pretty cool. No, okay. So the best, by the way, the best prank on the students would be to actually print out that tree and hand them like physical copy so they can easily just take it, grab it and clank format it and look at it. So they had to actually type it out like on a computer, or at least use OCR or something. That would be actually pretty funny, I think. So it adds additional layer to the challenge, I think. Sorry, coming up in the middle here, what is bow, freq, and prop? Bow stands for bag of words. Bag of words. It's a basically model that is used, you know, in machine learning and stuff like that. It's a pretty simple model. It's a simplified representation used in natural language processing information. So essentially, it's a map. It's a map, word, and how often that word like occurs in a text. Seriously, you take a text and you just squash it into a bag of words. Like, for example, here likes in this sentence like occurs 2 times, and that's essentially what it is. And we actually have 2 different kinds of bag of words. Like this bag of words contains frequency of these words, right? And we also have a bag of words that contains probability of these words, right? So bow is parameterized either by frequency or probabilities depending on what we need. Right, so that's basically what it is. So this one tells us how often a word happens in the text, and this tells us what's the probability of it. And of course, you can compute the probability of that word based on its frequency, and that's exactly what we're developing here. We're making a function that takes frequencies, bag of words with frequencies, and returns a bag of words with probabilities. And then we're going to use that to classify emails. Does it make sense? So yeah, goes by in a teletype to print the tree. Nice one. I'm really glad that you like the idea. So, and what we're essentially using here, you can check out the source code of this thing that we're developing here. I'm developing it just for shits and giggles, so for educational purposes. There's a couple of links that I use to implement all of that. We're specifically implementing naive base spam filter. Yeah, and we also like, yeah, I would just recommend you to take a look at these 3 links to get the idea of what we're doing, right? So we're implementing this classifier, we're using bag of words to represent the, you know, the model, and we're using this data set to train the model. So that's pretty much it. It's actually pretty straightforward. Summing up the words divided by the probabilities, right? Yeah, that's pretty much it. Yeah. Yeah, that's what it is. So there's a formula on the Wikipedia page specifically. So for a single word you would use this formula, right? And then once you calculated the probability for all of these words using this formula, you combine all these probabilities using this formula, and that's exactly what we're doing. So it's actually a pretty straightforward process. Alright, so how can we convert all of that? So where is my function that I'm trying to implement? So frac to prob. So here's the bowl. And first of all, I need to, for a single word. Yeah, so what we're essentially doing here, we need to compute how many words in general do we have in a bag of words, right? It's going to be n, and I can just essentially copy paste it here, right? So we take a bag of words, we convert it to a map, then we look up a specific word. But do we really need to look up a specific word? Yeah, we need to count the words. Yeah. I'm just thinking what would be the best way to do that. So let me go to REPL. And let me actually create a bowl out of a particular file. So I think I can just do something like this. Bowl from, yeah, I can just do bowl from file, which is quite convenient. Read file if possible. If it's not possible, return something. Nuligor, what's up? What's up, Nuligor? How are you doing? So let me actually read something. So it's going to be data, and where is the training set? I'm going to take something from the training set. I'm going to take something from ham, and can I just? I need to take a single thing here. How are you doing, Oliver, by the way? Haven't seen you in a while. Oh shit. The problem is that we have too many files here. We have too many files. Okay, so I'm gonna start by doing that. Pretty good, nice. Really glad to hear you. Are you working as an Elixir developer, by the way? Because I heard like you just sort of like pursuing that path. I'm like, oh, you're on vacation, nice. All right, so basically we can now build bag of words quite easily out of the file. So we give it a file and it gives us just bag of words, which is super convenient. You're gonna start in January, nice, good luck. A bowl from file cannot be done with only map, right? I'm not sure what you mean by that, but it returns a map. Well, you cannot parameterize the specific data type right now, but it's not like it's needed at all. It's not like it's needed. So right now it's gonna be a map. Because I only started developing it, like, I mean, we didn't have requirements when it needed to be something else. No. So I have that, and I need to count words. So when I'm counting the words, and maybe I want to do the following thing where I just do just bowl, right? Here's the bowl, and I can do count words. There we go. And we don't have this function. What is the count? Words count. It's called words count. There we go. Okay, so it's 18 words. So, and I'm pretty sure not monet is needed. Oh, you mean we should make bowl a monet? The problem is that you can make it. Maybe you can turn it into a monet, but I don't think it's needed right now. All right, so is it possible for me to take all of the keys of the bowl to map? So it's gonna be like that. So here are all the keys. Nice. So essentially, that's what I can do. I can now take all of the keys and map them correspondingly. Maybe I don't even have to map it because I can just take to least. Yeah. I think I can just do to least and just map that and compose it back onto. Perfect. Okay, I think I found it. I think I found the way to do that easily. I think I found it. Frec to prob. So here I'll have to save the whole amount of words. Right, it's gonna be words count bool. Then I do bool to map. Then I convert it to list. Right, I convert it to list, and then I want to map it. But maybe I can just map the map itself. I don't quite remember if you can. I think you should be able to. Well, map is definitely a functor, so we should be able to. But I want to check it out one more time. So map. We can try to check something like this. Is there any way? Oh, you can just do that. You can map the values, but we need to map keys as well. But do we need to? Yeah, I don't think we need to, so we can just do a map. So we need to convert this thing like this. So yeah, map is a functor. I guessed it. So we take x, which is going to be that, and then what I do is just do from integral x divided by from integral n, and maybe I can do something like from integral here like that, so you don't have to do from integral here. It's like this. So, and that will give you that. So let's try to compile that, and it didn't compile because why? Yeah, because I now have to convert it back. Do I have to convert it back? Yeah, I have to do it like this. And I have to convert it back to a bool like this. And it does work. Nice. And now, if I take the bag of words like this, here's my bag of words, I can take the frequencies and convert them to probabilities. And here they are. Here are the probabilities. Instead of frequencies, we have probabilities. Epic. Absolutely epic. Nice. Cool. So now we need to use all of that. So our spam model expects bag of words for spam and ham to be frequencies. We are about to change that. We're going to change them to probabilities, and that will break everything. Hopefully it will break everything. So we're going to go through all the compilation errors. And there we go. So here we're reading bool from folder, and on top of that we can just do something like frequency to probability, and then yeah, frequency to probability, and let's try to compile that one more time. And it fails in other places. So we have a word probability, and now to calculate the word probability you don't really need to use this function anymore. Right, you can just look up that probability for that specific word. To be fair, we can try to change, yeah, this function to accept bool with probability and return probability. And that way you'll have to do the following thing. You'll have to do bool to that, look it up. Right, and if it doesn't exist, it has to be equal to 0. I think that's the thing we can try to do. What about common words like we and all, hello? Do you include them somehow? Yes, I do include them. So this model, if I understand correctly, may take that into account, because these words are present in both ham and spam dataset. So if I understand correctly how the model works, because they're present in both of these sets, they will kind of cancel out. But I'm not an expert on these kind of things, so yeah. So because we're actually not considering like only spam messages. We consider both spam and not spam, and we're calculating probabilities of both spam and not spam, and we know for sure which words are spam and not spam. I think I'm gonna compare some. Yeah. So we take into account as much information as we can. If a particular word is occurring as often in spam as in ham, I think the model will just cancel it out. I think it will just basically throw it away. But I'm not sure again, so I'm not an expert on these kind of things. And it seems to be, it compiled? It just compiled? Okay. So let me double check the thing here. Okay, so word was that. N would be 0 if it doesn't exist, so it will make it 0. Okay, that should be it. That should already speed up the model quite dramatically, if you think about it. God damn. Okay. I didn't expect that it's gonna be that easy. Alright, let's take a spam model. So it's probably gonna take some time. I hope that it finished classifying things. So now we can try to classify a folder. Right, so we're trying to classify a folder. We provide this model here, and the folder is going to be what? Data, validate spam. Let's try to validate spam and see if it's going to do a thing. It still takes a lot of time. God damn. It didn't really help. It still takes a lot of time. Why does it take a lot of time? So what we're doing here, we're classifying a file, right? So we're reading file, then we're classifying a text, right? Text probability spam. So we take the words, word probability spam. So it should be just a single lookup in a map, but it is not. Yeah, it is not a single lookup in a map. That's what makes it so weird. Like, why? Why is it still slow? Why is it still slow? We need to start investigating. So we're classifying text. So reading this thing. So the slowest part is probably somewhere here. Probability spam. So we take the words, and for each of that word, we're computing that. In that word, we just look it up, and we just calculate a simple thing. It shouldn't be that slow. It just shouldn't be that slow. So maybe we should start tracing things. How about that? What maps are we using? Is it lookup? I don't think the problem is with map, because we don't really have. It should be actually at least log n. Should be at least log n. Let's try the following thing. Excuse me. Cabal version 2 repo. Okay. So spam filter. Spam model actually. Let's take a look at spam model. It takes some time to load it up, but I wonder if it actually forces it. Okay, so then I can try to take the spam bow out of here, and then bow to map, like bow to map, and then try something like, is it count or is it size? I don't quite remember. Size? Yeah, it's size. And let's take a look at the size of this thing. Okay, so I think I know what's the problem. The slowest part of this entire thing is training. Since Haskell is a lazy language, it wasn't training anything on this step. It wasn't training anything. It starts to train things when I try to access them. So that's what's going on here. So it's not the lookup that is slow here, it's actually the training. And this is one of the problems with Haskell, is that you never know the performance applications of things. Like, yeah. Okay, here's one thing, and the second time it's gonna be actually quite fast. So here's a spam bow. Maybe I can take like 2 lists and actually take like 10 elements out of it just to see. So, and as you can see, it like waits a little bit before it gives you these probabilities and stuff. So yeah. So what about Haskell? We can actually like sort of warm up the model before trying to train anything. Yeah. But even that is not enough. Even that is not enough because some of the specific elements of the map still may not be fully computed. Which makes programming in Haskell really painful, because like laziness is just does its own thing, and you have to constantly think about laziness and situations like that. It's just, it is what it is. And yeah. Is it deep sec time? Why? How does it solve any problems? Usually don't stream much Haskell. Why I decided to do this spam filter in Haskell? Because I wanted to. Okay, so this is what we have here, and will it be possible to classify this kind of thing? So, classify folder, and we provide a spam filter, data, validate, spam. So we have only 100 things here, and let's see. Gonna do it. Still pretty slow. Oh shit, at least it did something. Okay, at least it did something. What's interesting is that, okay, in the majority of situations, at least it said 1. At least it said 1. And for the ham, by the way, basically this is the probability of this being spam. So for the ham, yeah, the probabilities are mostly 0. Okay, alright. So I think I want to slightly change this classify text and classify file function. I think it doesn't really matter if something is ham or not. So let's quickly remove that. And this entire I think is going to be just spam. Probability ham is going to be gone. And let's continue. Yeah, and in here, I'm gonna just do that. Cool. So, yeah, the problem with all of that, you have to like pre-warm up all of these models before doing anything. But maybe we can try to do something like this. Essentially, it will force this thing to be evaluated or something. I don't know how like strictness work in Haskell, but hopefully that will do the trick. We'll find out. And then if I try to force this entire model, spam model, maybe it will take a little bit more time, but it didn't really take that much time, so yeah, spam. So let's try to run it and see for how long it's gonna go. Classify folder. Deep-sec and bang patterns are used for strictness. Cool. But here, like a sec sounds like a sequence, but we don't need sequence, we need an associative array. So, is there something like associative arrays for strictness? Okay, it's gonna take some time before it will finish training. Maybe I just should just rewrite it in a camel or something, where I have more control over laziness and stuff like that. So let's wait a little bit. So it was a random choice, no due to Haskell. Yeah, it's a random choice. Like it's just... Yes, it is a random choice. Don't really look into my choices too deep. There is no really meaning behind them, okay? Do you believe in me and my abilities? I don't even know you. Hello, Chagra was taken. Welcome to the stream. DeepSeek works for any data structures, while it is a recursive version of Sec. Doesn't really answer my question. But sequence is a sequence, but we don't have sequence here. We don't have sequence. No one ever believes in me. But do you believe in yourself, though? Do you believe in yourself? So if your problem is that no one believes in you, you can start by starting believing in yourself. So you're going to be the first person who believes in you, right? And then once you believe in yourself, you can start expanding the group of people who believes in you, right? So maybe you can find another person who believes in you, and so on and so forth. I believe in you, stranger. Sure. Invalid contents, invalid byte sequence. Okay, there is definitely something weird with these things, and now we can try to explore why. Okay, so here is ignoring nans and stuff like that. Ignoring nans. On the spams, it gives 100% that they're spam. You see, this is a validate state, validates folder. It never saw these models, these emails before, but more often than not, it classifies them as 100% being spam. So if you try to do the same but for the ham, more often than not, it will tell you that it is not a spam. It will give you 0 or very, very low probability, or sometimes none. I have no idea why sometimes it gives none, but we can look into that a little bit deeper at some point. You see? You see my point? You see my point? But yeah, I think we managed to speed it up. But we still need to wait quite a bit for the training, and I think, and I wonder why exactly the training is so slow. I don't think it should be that slow. My hypothesis is that we're using the monoids for that, right? So we're using the monoids thing, and I think it just generates too much memory to do all this. Holy shit, I didn't think of that. You mean starting believing in yourself? Yeah, that's actually a pretty good trick. It's a pretty cool hack that I use all the time. So if nobody believes in you, well, maybe you can become the first person who believes in you. And yeah, the problem is automatically solved. Cool. So yeah, I think we managed to speed it up, but we still have a bunch of bugs. But at least we speed it up. Okay, so we're gonna do cache probabilities up. Cache probabilities to speed things up. And I'm gonna push that branch right into the repo. If you're interested in what I'm doing, you can check it out here. I leave the stream for some minute and you're already talking about beliefs. I'm sorry. Couldn't resist on the bottom. I'm really sorry. Okay, so yeah, look at that speed, by the way. So this is how quickly we classify emails, right? So here are the files with the emails, and this is the probability of them being a spam. Okay, sometimes we have none, but this is a separate bug that we're gonna address. But we know 100% that they're not spam. And on the majority of them, excluding nuns of course, it says that it's 0% probability of them being spam, which is quite good. And for example, for some of the spams, more often than not, it will tell you that it's 100% spam. And by the way, the model never saw these emails before. It never saw them before. It's a validate set. And of course, there's like a crash here, but we're gonna fix all that. STVC, thank you so much for Twitch Prime, your first subscription, by the way. Thank you, and welcome to our epic machine learning club. Thank you. What was the change that speeded it up? I missed it. Well, I explained it 2 times already, and the change was exactly what I was explaining. We switched from frequencies to probabilities, so we don't have to calculate the probabilities from frequencies all the time. We basically cached the probabilities, right? Should these numbers be between 0 and 1? Yes, they should, and in fact they are. This is a number between 0 and 2. Change my mind. If you think this is not a number that is less than 1, throw a stone at me. This is a very small number. It's pretty much 0. Yeah. So they are. But sometimes they are none, and I don't really know why. And this is something that I want to really explore. So I'm thinking, can we actually turn this into some sort of a, like, a demo that we can run? It's not really. So, I want to turn it into some sort of a demo. So we're going to have a spam model, right? Spam model here. And it's simply going to be classifying a folder. Classifying a folder, and the folder is going to be data validate ham. Yeah, so this is going to be that. So this is the folder I want to classify, just to check that it's a ham, and another one is going to be spam. So we might as well print something up, like put strln absolute ham, and yeah, after that absolute spam. So I also want to actually add a little bit of like line between them, so they're visually different. So yeah, and this is going to be our thing. And does it compile? And then I can do something like this. Right. First of all, it's going to wait a little bit because it's training the model. Yeah, because of the laziness of the Haskell, it's training the model right now. It's training the model right at the moment when it's trying to classify things, because it postponed the training of the model until you actually needed it, and now you needed it, and now it starts training it. Welcome to the laziness, by the way. I love Haskell. It's absolutely beautiful. That's why, like, it just cannot classify until it just finishes training. Yeah, it's like, yeah. It's like me, yeah, exactly. I'm starting to think that maybe laziness is like, it's cool on a paper, but in reality you don't really need it that often. That's really lazy. So it's supposed to train itself before it printed any of this. Right, and I even put it before I, printed all of this, but I didn't need it up until that time, and yeah. I think with laziness by default, you like lose a lot of control over your program, and you really need that control if you, want to develop something seriously. I don't know. I really like how it is implemented in OCaml, that by default it's strict, but sometimes you can mark particular things as lazy, and a lazy expression, and there we go, it's actually started to do things. And on the second run, I think it's going to be faster. It's not going to be faster. Yeah, it's going to retrain it one more time. Yeah. So, but once it finished training, it's actually classified things really fast. So we can add it to Doom. If it was training before, will it make a difference? Well, at least it won't print the weird text, right? So the problem is that it just prints this weird text first, which I don't quite understand why. Maybe we can pre-train the models and just dump them as CVS. Why not? Let's just dump them as CVS. Okay. CSV, yeah, sorry. Comma value is separated. Dump bow. CSV. CSV. So we're gonna accept the bow, and I suppose we can accept it as this, show A, right? Show A. This is here. And we'll also accept file path, and it's gonna perform like a side effect. Shit. So how are we gonna do that? How are we gonna do that? Word doesn't really contain any special characters, so we shouldn't really worry about that. So this is gonna be bow, this is gonna be file path, and the way we're gonna do that, we're gonna take a bow to map, then I'm gonna do m to list. Right, I'm gonna do m to list, and I'm gonna map this entire stuff to what? So it should contain a single pair. Here's the word, and the some sort of a value, because we don't accept neither frequencies nor probabilities, so it doesn't really matter. Sick haircut, thank you. I really appreciate your kind words. Thank you, thank you, thank you. And this is what we're gonna have here. So it's gonna be something like that. It's gonna be word, and it's gonna be value, and the value is gonna be showed like that. Yeah, there we go. Cool. And then I'm gonna basically join everything with new lines. And do we have something like write file? Write file. Yes, we do. Nice. So that means next I can do something like write file. Where do we write in all of that? We are writing all of that to file path, and I think that is it. So let's see if it compiles. Okay, it does in fact compiles. And let's try to dump some stuff. So it's going to be SM, spam model. So here's a spam model. So we're going to take some, we're going to wait some time. Spam bowl SM. So we take that. It's a spam bowl with probabilities and stuff. And I dump bow CSV. I provide the bow, and then we're gonna have something like spam CSV. And let's wait. Oh shit. Okay, did I have to? Oh god damn it! I forgot to reload everything. Now I have to start over again. Fucking damn it! I have to start over. Yeah, there we go. Now we have to wait until it finishes everything. And yeah, finishes everything. So welcome back, LLXOR. I suppose you were AFK. We already switched to a different project, so we continue working on a spam filter in Haskell. So right now I'm trying to speed up classification. As a matter of fact, I already sped up classification. The only slow step is the training. So instead of making the training faster, I'm gonna just pre-train everything, and I'm gonna dump it to a CSV file. And that's how I'm gonna go with that. Yeah. So, but I have a couple of ideas on how to make the training a little bit faster. So I might as well actually edit to do. How do you update these new training values? Update these new training values. I guess you don't. If it's in probabilities, it's not updatable. If you want to update it, you have to store it in frequencies. We might in the future store them in both frequencies and probabilities. Right now, they need to update it. It's kind of outside of the scope right now. So what we need to do, we need to make things faster and more correct. And then we can think about, you know, extending the model and stuff like that. So it's kind of outside of the scope. It's kind of outside of the scope. Okay, I think it did it. And now if I go somewhere here, spam CSV, so we have 3 megabytes of CSV data. If I open it with Vim, here you go. Here you go. Here are the words and their corresponding probabilities. Isn't that amazing? I think it's quite amazing. So I think we need a function that will load a bow from CSV. I think it's quite important. So load bow CSV. So we're gonna accept thing that is readable, and it's gonna be bow A. file path. Actually, it's going to be just file path, and what you will get a bow A. Okay, so this is the file path, and what we're doing, we're reading the file. So here's the file path. Then we split everything by lines. For each line, well, to be fair, we'll have to actually inject it like this. So here's the lines. Then we map all of them like that. So here's a single line, and what do we do with it? I think I don't quite remember. I think you cannot easily split it, but if you use text, you should be able to. And I think, yeah, if I do REPL right now, it's not gonna work, so I'll have to do something like this. Lines. Okay, cool. So I can do it like that, then I have that, and here I also probably have something like split, right? Split on, aha. So if I have something like this and hello world, cool, that's exactly what I need. So I know that this is not like a proper CSV parser, right? I know that, but I don't really need a proper CSV parser anyway, so T split by comma, like I'm splitting the line by comma. And here I expect to get two things, right? I expect to get two things out of that. The first one is going to be the word, and another one is going to be the value, right? And in here, I expect to get a pair where I'm going to wrap this thing in a word, and I'm going to read that value. Can be split dot. I don't think it can be. Okay, so we map that, and then map from list. No, I don't think so. No, I don't think so. So okay, so we have a from list, and then what does it say? Yeah, it has to be bow. So that means we'll have to do something like that. And is it working? Is it working? No, it is not working. Because then I have to pack it into that. I think that's what I have to do here. Is it gonna work? Couldn't match text with char. Couldn't match text with char. Oh yeah, I have to unpack it first. I have to unpack it. There we go. And I need overloaded strings here. Okay, I need overloaded strings. Overloaded strings. Why don't you want to work? Is string split on? Okay, cool. Finally I did it. So now we should be able to load these models from this thing as well. Cool. Cool. So let's see how quickly we'll be able to load it up. So that's kind of important. Load. So let's reload everything here. Load whole CSV, and we're gonna provide spam CSV. And I think we'll have to also specify what we expect from it. I expect to get some sort of probabilities. Spam bowl. SB. Let's call it SB. And so if I try to do something like bow to map, it's actually load. Well, I mean, it loaded up really quick because it's lazy, right? It probably didn't really load it up. Bow to map SB, and then I can do something map size. And it's faster than training. Yes, it is faster than training. Okay, cool. So we can try to do something about that then. We can try to do something about that. We can dump both of these models, and then instead of like training them every time, we can simply load pre-trained models. So this is one of the things we can do. Okay, so let's go with something like this. We're gonna go with train. So this is the train, and we're gonna put something like put strln training ham. Right, so this is gonna be that, and training spam. So, and in here I need to take the spam model, right? So maybe to be fair, when I'm doing spam model, this is what I need to do here. right, so here's this ham, here's the spam. So we're training them from these folders, and then we converted them to frequencies, and then I want to dump them to the corresponding places, right? We're gonna do dump bow CSV, dump bow CSV. So the first thing is the bow itself. It has to be ham, and we're gonna save it to data ham CSV. Similarly, we're gonna have a spam CSV. All right. So this is basically what we're gonna have, and we'll have to wait a little bit. And I'm gonna reload everything, and I'm gonna say train. Okay, welcome back, Duke. Does anyone have any questions about what we're doing? So I essentially decided to go with pre-training the models first, because loading the pre-trained model from CSV is faster than training it over again. But we'll see how it goes. Alrighty, training ham, going ham, haha. Oh shit, I'm already streaming like for 4 hours. It's very unusual for me. It's very unusual. Does anyone have any questions for like about what we're doing? So the ham is done. The ham is done. So here's the data. So here's the ham. It's 1.7 megabytes. So here's the data with different words and their probabilities. Training spam. Maybe we should multiply the probabilities with something because they're so small. What do you think? What ML library are you using? What is a ML library? Let me take a look. So I'm using like 5 third-party dependencies. So here's the base, which is the standard library of Haskell. So text is alternative faster strings for Haskell because the strings in Haskell by default are very slow. Then I use containers. Containers implement the the common containers like maps, sets, and so on and so forth. I use them quite a lot. I also use directory. It allows me to work with directories regardless of the operating system. And I also use byte strings, which allows me to work on the level of like bytes. It allows me to parse binary data. This is what I use so far. Is any of those ML libraries? I don't know. So are they ML libraries? Maybe they are. I don't know, to be fair. So that's the only third-party dependencies that I use. And they're not really third-party because they come with the distribution of Haskell. I think they all come with GHC. I think so. Okay, so we pre-trained everything, and now we have a model of ham. Spam is actually a way bigger model. Would you look at that? Would you look at that? And now, if I want to load the spam model, right? Spam model. Instead of loading it like that, I essentially gonna do a spam load bow CSV data spam CSV, and here like that. There we go. Base is pretty convenient, yes. The base package is great. You can always depend. Yes. Hello Ford, by the way. How are you doing? We are writing a spam filter. How about that? Isn't that amazing? I think it's kind of cool. Alright, so I pre-trained the models and shit. So let's see if it's easy now to classify things. Yeah. It's actually way faster than it was before. Look at that. So this is how much time it takes to, you know, like load up the pre-trained data and start classifying things. And it's way faster than it was before, because before it was like this, right? Because it starts training right now and then it will try to classify. Can you unimport base? I think you can. I think you... Oh, you mean the namespace itself? It's a good question. I don't know. So that's how it was before, by the way. It's gonna go for several minutes right now. Yeah. But since we are pre-training this kind of stuff, right? Now it's as fast as this. But of course it crashes here for some reason, but that's a completely different problem. So in my opinion. Yeah, so our goal was to speed this thing up, and I think we managed to do that. Though, yeah, here are the models, and I think I'm gonna commit them as well. I think they're a couple of megabytes. I think they're gonna fit into this thing. All right, so I'm gonna add a readme, and I'm gonna also add a quick start. Quick start. So in a quick start, I essentially going to explain a very simple thing. You have to cd to data, and then you have to call the data prepare data script, right? So it will basically unpack all of the training data for you and stuff like that, which is quite important. And it also will split the data into the validation set and training set, so you don't have to worry about that. Then you have to go back, and then you have to do cabal version to REPL, and it will try to validate the data for you. So this is basic workflow here. Okay, so I'm gonna remove that. Okay. Now, oh my god, it's trying to show the difference. Okay, pre-train the model to speed validation up, right? And also add quick start instructions to me. I'm going to push that right into the repo. So this is a separate branch, and I think what I wanted to achieve in that branch I already achieved, even though it's not like 100% correct, and we still have some mistakes, but I think they should be fixed in the scope of the separate issue. Is Haskell your favorite programming language? So it's an FAQ, yeah. So this answered in my FAQ. Thank you so much. All right, so yeah, our goal was to speed up the classification step, and here's how fast it go now. So we just run the Haskell. You need to wait until it compiles, of course, and then until it links. And yeah, so it already runs classification. Of course it fails, but it's a completely different issue, right? It fails, but at least it doesn't like take too much time to classify and train, because we sped everything up. And now I'm gonna just merge everything. No fast forward, this one, all right. Oh shit, what the hell is going on? I think, oh yeah, okay, so then I can remove that. Cool. And I'm gonna push that right into the repo. So the source code of everything I do here is available in this repo if you're interested in that. Of course, there is a lot of problems here. As I already said, sometimes it returns none. I have no idea why, and sometimes it crashes because it cannot read the data properly. But I'm gonna try to fix that next time. So maybe we're gonna do another spam filter in Haskell session at some point. And we're gonna try to fix all of these small problems here and maybe improve the infrastructure of this entire thing. So yeah, and I really like that, yeah, for just spam, if it's a ham, in the majority of situations it just tells, okay, it is very unlikely to be a spam. If it is a spam, it is very likely to be a spam. And it never saw these emails before because they're part of the validation state, like validation set. They were never used in training, so it's completely new emails, and it managed to successfully classify them as spam or ham. What's up, Jiang? I hope you enjoyed your dinner. Look at the speed now. Now if you try to run it, yeah. So this is how much time it takes to load up pre-trained models and start to classify things. Yeah, but again, it fails sometimes, but it fails for some really strange reasons. So there's a problem here that it cannot invalid byte sequence yet again. Sometimes we get nuns, but the main focus was today on the performance, and I think we managed to improve the performance. So the way I did that, I just basically cached the probabilities. It's the first thing. We don't recalculate them all the time. And I also cached the models themselves. So I pre-trained them, right? I pre-trained the model, put them in CSV, and here they are. So basically you have a word and the probability of that word being in either ham here or a spam, and that speed up things dramatically. So yeah, I think next time we're gonna try to address all of these problems here, and yeah, we'll see how it goes. I don't know when we're gonna have another like spam filter and Haskell session. Maybe after Advent of Code on Thursday, on a day off, we can do that, because it's kind of an interesting casual project. But yeah, that was cool. Unfortunately, boys and girls, it is time for me to go. Today's streams was actually kind of cool. I programmed them in Scala. I solved quite easily one problem of Advent of Code. So probably the next problem is going to be my last one, because I heard a lot of scary things about the next problem. I don't know what it's all about, but people are just, saying that they don't like it. So maybe it's going to be the last one for me. Maybe I won't be able to solve it. We'll see. But in any case, thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you tomorrow. Tomorrow, according to the schedule, we're doing a game development in C++, but since there is Advent of Code in place, first we're gonna try to solve Advent of Code problem, and if we have enough time, we're gonna do C++ game development. Also check out the schedule for more information on different projects we're working on. We're working on different projects almost every day, but Advent of Code kinda derailed the whole month. Also check out our VODs channel for archives of the streams. This stream is going to be there, but tomorrow we upload them on the next day. And also check out our Discord server for offline discussion with the community. And let's maybe rate somebody. We haven't rated anybody for quite some time. Do you guys have any suggestions on who to rate, except Soding, of course? Because we rated that guy so many times, I think we need to give a chance to other people. So, and I need to wait until my Twitch loads up. So who's that in my recommendations? PowerShell. And I need. To be fair, Toggle. I think ToggleBit rated us recently, so let's actually rate ToggleBit. Alright. Get ready for the raid, boys and girls. Get ready for the raid, and I see you all tomorrow. Love you.